Hello and welcome to another Out of Spec Reviews video. Today we are going inside of Rivian's software and hardware development lab here in Palo Alto, California. I'm going to take you on a tour with some of the team members heavily responsible for Rivian's Gen 1 and Gen 2 products, but also we'll be discussing a lot about upcoming R2 and some other cool projects throughout the video. It's going to be long, in depth. You're really going to learn about some of the key people inside of Rivian creating amazing software experiences in the vehicle. We've done so much with Rivian over the years, going on track, road trips, off-roading. There's some of my favorite vehicles on the planet. And really, this is a cool opportunity where we get to go behind the scenes. And it's going to be a long one, it's an out-of-spec video. We're going to go behind the scenes and really meet the people responsible, and they're going to give you so much background information about what makes engineering a Rivian unique and why having a vertically integrated software experience tied in with the hardware absolutely important. This video is brought to you by Iona, North America's premier charging network. With unmatched commitment to elevating the customer experience, Iona is opening America's roads to all EVs, giving drivers the coverage they need, the reliability they deserve, and the amenities they crave. Jordan joins me behind the camera. Dude, are you pumped for today's video?
I'm super excited. I like these deep dives. I like visiting the companies that let us visit.
You know, it's always hard to make software sexy in video, right? It's easy to get into Rivian and show drift mode and sideways everywhere, but daily experiences, having your app connected to the vehicle, with your phone as a key, just with great route planning, a new energy app we're going to debut today in this video as well, talking about, a whole new charging profile, a whole new way to manage the energy of the vehicle. That's going to be super cool. We're going to debut that. They've also done some fixes for the dual motor drivetrain that I've been asking for a long time. So it's going to be a little bit of a hodgepodge, but we're here for multiple reasons, and I want to bring you guys along with me for the Rivian visit. So strap in. Jordan, you can throw chapters through the video, right?
Yeah.
Okay, and join us for a full tour of inside Rivian's Software Development Center. Jordan, we are heading into the Palo Alto Rivian Engineering Center. It's a really cool building, actually. It's just like super peaceful, really nice. They have like 4 or 5 buildings in this little area. And so first, I think we're going to meet with Vidya, who's responsible for like the electrical hardware. So that would be like ECUs, cable management in terms of wiring harnesses, making sure that, the hardware, not only for Rivian, but the JV with Volkswagen Group is kind of dialed in. And we're going to talk a lot about that. Then we're going to meet with James, who's responsible for driver assistance. He'll also have his colleague Nick with him. We're going to debut a new driver assistance feature. It's not going to be out yet. It's going to come soon. A little bit of in-lane repositioning, which I think Scott, who just got her R1S, is really going to appreciate on our team. And then we're going to meet with Wasim and the whole software side of things and talk about the new energy app that they've created based on a lot of our feedback, as well as improved charging performance. Just step this way a little bit, as well as improved charging performance and a bunch of other little tweaks, including a clutch disconnect reconnect strategy for dual motor that won't make it as clunky to drive. With that said, Jordan, we're going to go get with Vidya right behind those doors, get in through the ECU stuff. It's going to be super nerdy.
Let's do it.
Let's do it. Guys, we're inside of the Rivian office with Vidya. Nice to see you again.
Nice to see you, Kyle.
So we're going to go on a tour, and I have no idea what the heck we're going to look at, but with you, it's going to be some cool electrical architecture stuff.
Lots of cool electrical hardware, the stuff you can touch. Yeah.
Cool. So maybe you can tell us a bit about the office and anything on the way over there.
Yes. So you're in our Palo Alto, Silicon Valley office, and we sort of came of age during the COVID era. So we have multiple locations, but each location has some sort of synergy with, and a reason for existing where it does. So our location in Palo Alto is very synergistic with Silicon Valley. So what we do a lot, we have many diverse teams here, but a lot of our focus here is on stuff that has synergy with high tech. So like infotainment, telematics, ADAS.
Fun.
Which is very synergistic with what goes on in this area.
Yeah.
In Irvine, which is I think where you visited, we have a lot of our teams that do body, chassis. And so my teams build all the hardware for Rivian. And so the teams that do the zonal controllers out of Irvine.
Oh, interesting.
Because they control a lot of the, traditional vehicle, the chassis,
body and chassis
all of that
related
stuff. And then the teams that do infotainment, telematics, all that good stuff are based here.
It's amazing. And before we get in the tour, our viewers know this. We've done probably 100,000 miles in Rivians to this point, and the infotainment is amazing.
Yes,
so,
yes.
So
always
room for improvement, but it's so good.
Come on over. So today's a Friday, so it looks a little more quiet.
Yeah, and it's a Friday before a long weekend,
Exactly.
so people are probably
Yes.
out.
Exactly.
What happens generally in this
So
area
this
here?
is where a lot of our software teams work from, and they tend to be also often more that they can work much more easily from anywhere because you just need a laptop to code from.
Okay.
But a lot of our software teams will sit here, and we'll keep walking that way, and we'll sort of turn around.
Dang, yeah,
And
this is
you'll
a
start
beautiful
seeing
place.
some of the fun hardware. Yeah, the funny story is this building was built for Rivian was a company in those days, but the story, at least it could be an urban legend, is that they were worried if the company failed.
Oh, okay, yeah.
That what would happen to the building. So they built it so it could be turned to a school.
Oh, interesting. Okay.
yeah.
Well, now we're getting into some real hardcore stuff over here.
That's
Okay,
right.
nice.
So what you'll see here is a lot of our hardware systems where we're running tests. You know, you just talked about how we love our infotainment.
Yeah, really
and
do.
these are sort of hill racks, right? Hardware in the loop racks. Where we're constantly testing.
Yeah,
different
and are we okay to
configurations.
show some of this stuff here?
Yes. we can
Okay,
show
cool.
this,
So
yeah.
essentially, hardware in the loop for the viewers at home. This is, where you have almost a simulated car on a rack,
That's
in a
right.
sense.
And this is the infotainment portion, not everything, but it's more focused on the infotainment and telematics piece. So that's why you'll see all the displays.
Yeah.
And
Well, they're
then-
not living our out of spec lifestyle because everything's full charged. We got to get some like 1% lifestyle over here. But yeah,
Some of us that live dangerously have taken it there many times.
amazing. Love it. Yeah, I've been there a lot. But super cool. So you essentially have, I assume, Gen 1 and Gen 2 racks. You can verify software updates.
That's right. That's right. We're constantly running because every time we release software, we want to make sure it's robust. We run, tons of cycles.
Yeah, and maybe, throughout today, I'd love to learn kind of how that process works
Yeah.
as well, what validation steps have to go through.
Right, right. And actually, as we walk along, we can talk to you. We find, and we're going the other way around, but we really start, validation. I used to work with somebody before. It's like he always called it a three-legged stool, but it's really a multi-legged stool.
Yeah.
You really want to validate it in many different ways. And that's what you'll find is what you're seeing here, what we call a subsystem. So that's like an infotainment level subsystem.
Sure.
What I'm going to take you to is what we call a lab car,
Okay. Yep.
which is pretty much the entire car put together. And so that would be a system as opposed to subsystem.
Sure.
And there we're, testing all the electronics when it comes together,
Yep.
right? It's not, and it's when we build a brand new vehicle
Thanks.
is when it's the most interesting. Let's
Okay,
come this
cool.
way.
Great.
So come on over. This is our land of lab cars.
Oh, this is amazing.
Yeah,
So
so-
cool.
Does this remind you of your vehicle?
Absolutely. This is one of my favorite things on the planet. Love the, I guess you would call it the RCV. Rivian
EDV,
commercial
RCV, many
vehicles,
different,
yeah.
it's had many names. Yeah, the RCV is a Rivian commercial van.
Yeah. And it's funny that you kind of did it in the shape of the
And
vehicle.
that's very deliberate. So let me tell you why. So these are all, frames representing different vehicles. You can look at it and you can tell this is a T, it's an R1T. There's probably an S somewhere, other vehicles around.
Yep.
We build it exactly to that same length and specification for a reason, because we actually use production harnesses. And you want it to be as representative of the actual vehicle you want to build. So the way the design process works is, we build a lot of our hardware in-house. So we start out building our controllers. In our case, say in a Gen 2, we build the zonal controllers in-house.
Yep.
We first test them on a bench, just board by itself, figure out, find issues, fix it, probably do another spin of it if we have issues. And then what we do is we test at a subsystem level, right?
Yeah.
So put a few of them together. So let's say it's the infotainment. I put the infotainment together, display, which is sort of what you saw there. And then you test at a subsystem level to make sure it works. And when that's healthy, we come sort of to the next level. This is the top level. So before we ever build, and you've probably been watching RJ posting all the R2 videos.
Absolutely. I've seen that. Yep.
Before we build a vehicle, we build a lab car, which is this sort of representation of it. It has all the electronics. It has the exact same parts, and it has all the harnesses, exact production harnesses. And the reason we do that is you want to capture all the signaling effects, the EMC effects in the most representative way.
That's what I was going to ask about. So, once you start putting this wire next to that wire and you start putting loads or simulate fault cases,
Exactly.
I guess weird things can happen that you wouldn't expect.
Absolutely. So that's the goal here, right?
Yep.
And so we put it all together here and we test it. And we have different versions of this. In the early days, we just did the low voltage. And now we have multiple versions. We have a high voltage version. We
I'm
would
looking
have
at
a
some
pack
orange
underneath.
cables right
Yes.
here at least, but maybe you're not running high voltage
Here
through
we're
this
not running
one.
high voltage,
Yeah.
but we have versions that'll have a high voltage underneath.
Wow.
And so that's the next level of integration. So we're really fully sort of encapsulated, right?
And this isn't totally unique in the auto industry either. A lot of other automakers will
Right.
go and do their bucks, but is there anything specific that you would say is like totally different to the approach you guys take at Rivian? I mean, I love to see all of literally the size of the vehicle
Right,
is kind of
right,
cool,
right.
but it, you know, sometimes you just see them all in a box.
That's right. And I've seen them, all in a box, and that's something. I think what's I wouldn't say that in itself is unique, but I think what is unique to us is the vertical integration approach. So a lot of this stuff was designed in-house, right? So let me try and find you. So this, for example, this unit here is one of our zonal controllers over there, right? It was designed fully in-house. And so what is unique is by the time it comes here, we fully understand like every transistor on that thing.
Yeah.
We tested it. We understand the software that's running on it. And when we put it all together, we're not sort of wondering, why doesn't it work? Or what's wrong? It's our, I would say that the distinguishing feature is how we start out designing the vehicle. We start with a clean sheet approach where we say, how do we want to do this, right? And then we go build it and then we put it back together. So we understand it probably much more deeply than is possible in a traditional tier 1 model.
Well, of course. And so we did the video, it's got to be a
Right.
year ago now when Gen 2 launched.
Right.
And, completely redid the entire electrical
right.
architecture with your own controllers. What was that process like? I'm sure you could go on for hours about it, but just briefly, I mean, there's very few automakers, especially large
Right.
automakers, that are bringing so much in-house like you guys are. Obviously, that was a big lift from your side, I can
Right,
imagine
right.
as well. But that really, I think, set the standard for
Yep.
Rivian's future, in my opinion.
No, that was a huge lift. And I think once we launched R1, the goal was to get something to market and, that people would love. And we got that. And then we looked at it like, how do we scale this? How do we take this to bigger volumes? How do we make this even better? How do we establish, we knew we were going to do an R2, a base that we would use for R2. And it was very obvious that we want to move quickly to zonal architecture because it has a lot of benefits, cost, mass, and it's even more scalable, I would say, in the long term. So we knew we wanted to do that. And it's sort of saying, rip the Band-Aid sooner than later.
Yeah.
We said, let's do it quickly. And you'll see and I'll take you to a Gen 1 vehicle. This is a Gen 2, right? This is zonal controller. Look at the harness. And we talked about how much
How much wiring you took out.
we reduced. We reduced 1.6 miles, which is really meaningful.
I also
and
love.
44 pounds.
I'm sorry to
saw that,
interrupt
right?
you, but this is so funny
I was
that
gonna
you
tell you that.
have the flashlight in the butt
Exactly.
right there.
I was just going to point you. So as I said, we have everything.
Yeah.
Everything that's connected electrically is here, including a famous flashlight.
Oh
right?
my goodness, this
And
is
you see the
hilarious.
speakers. Yeah, you see everything
So
here.
you could literally slap a battery on this thing, couple wheels, and you're good to go.
There you go. That's really the intent, right?
Yeah.
So so you asked about how much work it was. We'd really go back and we can wander over this way, but you look at all these different systems, and this would be, I can check, right? Yeah. So this is an older system, and you can already see,
Oh, yeah.
the proliferation of controllers that you'd see everywhere around it. So this is a very simple way to see. This is a door control module. That's on this door. We can go back and look at that one later if you want. There's none of that, right? And there's one on each door.
Yeah, let's go look at that one. Let's show.
Yeah.
I think that's a great example. Just to so many automakers are literally just assemblers of vehicles.
That's right.
And you guys are genuinely
You
really
see, that's gone.
going deep.
That
That's
box
amazing.
is gone, right? Doesn't exist.
And so
you see that all over the vehicle. Is that simplification? right?
Amazing.
And so what we had to do, and what you will notice if you look at this harness bundle, you can sort of do it. Look at this bundle, and then I'll show you.
Yeah, and really, what we're looking at, is Gen 2, that massive step change that you guys made. Even though the vehicle looks the same, they drive
Right.
very similarly. Underneath, completely different.
And I don't know how well the viewers could see it on camera, much simpler. The other big thing you'll see is there's this big harness over here. And this one's much more visually obvious. You see that thing that looks like a little snake?
Yep.
And we can walk over there.
Okay, so Gen 1's got the big snake there.
Yeah.
And then we're coming up to Gen 2.
And well, it doesn't exist.
There's
right?
literally nothing there.
There's
That's
really
amazing.
nothing,
And is
right?
that because you're separating the right and the left side of the vehicle, or are you doing front as a one major
I
ECU?
would say it's not one thing, but it's because we rethought the whole system and we looked. The beauty of a zonal controller is it's geography based, and the older controllers were domain controllers were function based.
Sure.
And so you could have something that controls lighting, and lighting is all around the vehicle, and a body control module that controls lighting, has wires running all over the vehicle. Whereas we call ours east, west, and
Yep.
south because the direction. The east is just working in the east, the west is just working in the west. You don't have this need to crisscross wires all over.
It's so key, I think,
Yeah.
in order to scale. And, as you get to more vehicles in the future, I guess smaller, less contented vehicles would need less zonal controllers.
That's right. If you had a very low cost vehicle, you could do less, right?
Yep.
When deciding how many controllers you have, you really look at the number of endpoints. Where do they go, and how do you balance the load, right?
And then to communicate between the controllers, do you just use Ethernet high speed, or?
So we definitely have Ethernet. So there's a Ethernet backbone that connects all the zonal controllers, and then we have CAN and LIN for lower performance endpoints.
Right, because CAN only can handle so much before
That's
it
right,
starts
yeah.
to get kind of
But that's
jammed up.
important. This vehicle has an Ethernet backbone for
Yeah.
sure.
Amazing. Well, this was always a dream of mine to come here and
Yes,
see
yes.
these, because I've seen them in photos and like other media have come and checked them out.
Right.
And just to see the sort of bucks out here is really cool. I didn't actually totally put together that they were completely life size.
They are fully life size. And I think what I can also show you out here, which is also something very interesting, is that silver unit out there. That's our
yeah, right up over
autonomy
there. Okay.
infotainment module.
Okay.
And if you see that, it's liquid cooled.
Yeah,
which
I
is
was
really cool. If you
just
think
gonna
about
mention
it,
that.
yes. If you think about the compute that's in a vehicle, and one of my colleagues likes to say it, the AI compute that's in our autonomy computer far exceeds what's on your MacBook or laptop.
Yeah.
Because that's what's needed, for all the self-driving capabilities. But very few people know that they actually have a liquid-cooled computer sitting under the hood.
Yeah, it's
right?
a legit
Yes.
high level of compute. And we're going to meet with your colleague James about like the software that he puts
Right.
on there. But it's up to your team, I guess, to make sure he's got the power.
That's right.
in
We
order to
designed
use.
the hardware, we designed the sensors. So, we didn't talk about it, but all the camera, this is like a radar, everything is here.
Yeah,
right,
and it's
in
the
system.
highest level of megapixel on any vehicle sold in our market.
That's right. That's
Yeah.
right.
And for Gen 2, not Gen 1, we all know that, but Gen
That's
2,
right.
great
Gen 2.
cameras.
That's right. That's right. And if you come back and look here, you see, as I talked about it, they're all here.
Yep.
You see them all. They're here. They're representative.
And how does that process go, more or less, to select the right hardware to use for cameras? When do you decide to go in-house versus
Right.
sourcing, from a supplier?
So it's very interesting. Gen 1, we were a new small company. We probably sourced modules from somebody, looked at them and said, I need a 1 megapixel camera or 2 megapixel, whatever it was, and we got it. As we came to Gen 2, we knew a lot more, and we said, that's not what we want to do. We said, I want to go pick the sensor. And so not all, 3 meg or 8 meg sensors perform the same. Some are better at low light, some have better dynamic range. And there's a paper spec, and there's actually what you get. So what we do is
Yes.
literally get the samples
Yep.
of all the sensors, actually test them in our labs, look at how they perform and over temperature, because sensors, room temperature is one thing, temperature extremes is another thing. And we actually evaluated, I would say, 4 or 5 different sensors. We then actually work similarly with lenses, and then we work with the module maker to really pair them together.
Interesting. So
And
you're
so
doing that even down to that level of
We
detail.
are, absolutely. So we're not just saying, give me a 3 megapixel camera or an 8 megapixel camera with this field of view. We're saying, we're going to build this camera. We find a partner to build it for us, but we spec everything down to the lowest level as to what sensor we use, what kind of lens we use. And you've probably seen the difference between our Gen 1, Gen 2 in
Yep,
camera quality.
absolutely.
That's where it comes from, right?
Yeah, I mean, that's what you get. I mean, but it wasn't that much time from Gen 1 to Gen
No,
2. And, to the average consumer, maybe they wouldn't know what goes in
That's
behind the
right.
scenes, which is probably a good thing because they just want to have a nice driving experience. But to nerds like myself and our viewers at home, like just the insane difference between these two bucks. Like
Yeah.
this takes 7 years in a typical automotive industry, and you guys really compressed that
In a
timeline.
couple of years, yeah.
Yeah,
We
so
did in a couple of years.
maybe you could share just a little bit of the secret sauce or a couple words on how that's even possible.
And I think there are 2 things that make it possible, maybe more than 2. But one is, I think, really the synergy with Silicon Valley and having that sort of fast fast entrepreneurial spirit where we really iterate quickly. The other thing is having that whole sort of vertical integration approach, because you can't really do that if you're not all on the same timeline, right?
Right.
You can't go to tier one and say, guess what? We have this really fast timeline. You've got to figure out how to make this change for me.
Right. They're like, well, we need 5 years.
Exactly. So that's the other one. And the third part is really since we have everything in-house, it's the hardware and software teams, we sit in the same building, right? So you walk over. And when you want to make a change, you're not, typically if it's a different company, you discuss the change you need, then you work with your product manager who then brings it to them. They create a scope of work statement, and then there's a legal contract. That adds a ton of time in the process. And the difference is you have an engineer walk over, there's a meeting, they say, we want to do this, and you agree and you move on. So that gives you a lot of velocity.
I think that's the biggest thing. I've been lucky enough to visit with almost every automaker and go to a lot of engineering labs, and just, on one hand, Rivian being a sort of a small, scrappy company is a huge advantage. And maybe on all hands, because I wouldn't say it's that small anymore.
It isn't that small anymore, yes.
But you guys, like you mentioned, you can go talk to the guy responsible for the door handle if you need to make a change. That just doesn't happen at large automakers.
Exactly. And I think that's if I had to pick one big thing, that's the biggest advantage, right? But we've also grown, we've scaled, and we're also learning. What we've got really good at, I'd say, in the last year is also the stuff that people have been doing for years, figuring out, we always had a very strong reliability team. So we don't design just to get something out the door. But when we actually build something, we test it for, the same rigorous standards as has to be for over, greater than 10 years or, under extreme stressful circumstances.
Yeah,
and so we
then
have
the
all
cars
of that.
end up in our hands and we put them through the extreme
That's
test.
right. That's right. So yeah.
Amazing. Well, thank you for showing us this at least. This was a dream of mine to come here.
We tested for bring-up testing, but we also tested for durability testing, and then we also tested at the contract manufacturer.
So when you're saying you're testing, this is all for the ECUs in the vehicle?
Yeah.
So you'll design the spec, run it through hot, cold,
Everything.
vibration testing, whatever a vehicle sees throughout its life cycle.
Yep.
Then you'll send that spec to a supplier to produce it, or you guys produce it here, or how does that work?
We produce it. We haven't built it as a supplier, but yeah. We give them the spec, everything, right? It's just built to print.
And then do you get a few off the line occasionally just to run through the test to make sure
we test it all the time at the end of the line. So we also give them the equipment to test at the end of line.
Oh, amazing.
Yeah.
So this is the room where you guys literally develop the stress tests for the ECUs, is that correct?
This is where we develop, actually validate that the tester will run fine, and then the stress tests are run in our validation lab. So there's one across the road, where we have the thermal chambers, the vibration, all the connections. But
And
this is where we make sure that it will work in validation.
Oh, very cool. Yeah, cool.
So in our validation lab, you see these gigantic chambers. It's a room full of big chambers where we have all these units. They either like seeing thermal cycle, they're being vibrated on a shaker table. And while all that's happening, we have these testers. You see, this is a test system of a tester. These testers are actually continuously monitoring. They're providing test stimulus, and they're continuously monitoring to see if it works.
So you really censor up the ECUs for something like this then? You put extra sensors in there to see how they're performing?
We test a lot from the I/O. Sometimes we'll put sensors, but we have a lot of sensors on the board itself, like thermal sensors, because we want to monitor even during vehicle operation.
Yeah, makes sense.
But I'll let you talk a little bit about what we do.
I'm going to hand a mic over to you so our audience can hear you, if that's okay. I'm just going to clip it right here.
Yeah, sure.
Okay, thanks. Sorry about that.
It's going to be improvised.
So our testers, we're there to test the hardware. So we basically need to access all the interfaces of the ECU and from the outside. So we will sometimes simulate signals that will allow us to make sure that we exercise the full capability of the hardware that has been designed. So we're not doing system in the loop, hardware in the loop. We're really testing the nets, the actual PCBA, how it's built, and for making sure that in the future, whenever we do an update for a new protocol or a new software bit, that it's actually something that the hardware is able to handle fully. So This tester, so what you see here is a fixture that we use at end of line. So our end of line tester is different than validation, design validation, engineering validation. What we do is that before we send it to the factory, we want to make sure that it passes final test. And so those will come usually with just a fixture. I don't know if this one can close, but basically we make it operator friendly. Right, and whenever it's closed, it starts scanning and do all our test suite. When the test suite passes, goes to the right bucket, and we get all the data, all the reports for that. So that ensures traceability as well for whenever there's a validation runs that ran over many weeks, many months. We can trace back all these tests to the same to every single unit that makes it to a car.
Yeah, very cool. Very cool. Thanks for showing us this. So we've walked down the hallway to the other side of the building, and things look totally different over here, but maybe even more nitty gritty. What's going on over in this area?
So this is our electrical hardware lab where the teams actually working on the ECU designs actually develop them here.
Now, do most automakers have labs like this, or do they just rely on tier ones to do this type of work?
Most rely on tier ones. There's the ones that really, adopt the vertical integration spirit. They would have something like this, but as you know, those are
very few
and far between.
Yeah.
So yes, so you can see our engineers working away on various designs.
So cool.
I think some of them are in meetings here, but you can come maybe take a peek from here, but you'll see they're all working on different boards.
And these are all your own PCBAs that are designed in-house.
That's right, in-house designs.
Yep.
And
got like a really cool
yes.
set of
and
stuff
in fact, if you look at this is probably the boneyard or, or something like that. You can see this is a ECU recovered from some vehicle.
Right, you can see all the thermal
from
paste
something.
off,
You can see all the thermal paste. So somebody was probably using for some kind of.
And these are probably not
test.
production grade thermistors or.
No, exactly.
sensors,
These were, we, as I said, we really stress test them. So we'll probe. We'll put some sort of
that's fun.
Testers. Yes.
Super cool. And so you can basically probe up a unit, throw it either on a test bench or in a vehicle, I guess.
So we look at many different ways. For example, typically I showed you our infotainment computer is liquid cooled, but if I'm actually testing it and I want to probe signals, we might put a really huge, this is a massive heat sink.
Yeah, that's obviously not in the car.
That's not in the car. As you saw, what you saw earlier was a liquid cooled system that actually controls it. But if I want to be probing signals, I can be liquid cooling at the same time.
Right.
So we have other ways. Right?
Amazing. Love that. Didn't even think about
yes.
that. That's so cool. I literally know nothing about electrical architecture, so this is a real learning experience for me.
Come on over and we'll show you a little bit. So, we have a little board put up here that actually gives you a sense of what we did going from Gen 1 to Gen 2.
Yeah, that would be amazing to show.
And as we've said this many times, we went from 17 to 7 ECUs. If you count this is more than 17. And the reason is because we have more than ECUs there, but it's there for a reason.
And did you go to eFuse for Gen 2 then?
We did.
Nice.
And
Very
that's
cool.
the reason you got it.
Okay.
That's the reason we have more than 17 here, because not only did we go from 17 ECUs to 7, we eliminate a whole bunch of thermal fuses.
Fuse
and
boxes.
those are now residing in these.
And they're resettable electronically, I guess.
That's right.
Okay.
That's right. Which makes it so much better from a service point of view.
Yep.
Exactly.
Very cool.
Yes. And it's, you really don't want somebody coming and playing.
Playing around trying to swap stuff. I could
That's
fry
right.
something. This is self-resettable and really love that. Now, most of these ECUs, did you design these in-house in a similar process?
We designed these too. So that's actually the important thing to know is we always had this vertical integration approach. Which is another reason we could probably make this transition.
Sure.
Most of these are all the domain controllers that the functionality of which then went into our zonal controllers. If you remember seeing, these are the door controllers that you saw on the door. So we always say we went from 17 unique in-house ECUs to 7 unique. So this is why this looks more than 17, because this is 4 to show you. There's really 4 of them on 4 doors.
Right.
But it gives you the scale of the change, right? What we're trying to show you here is all this went there, and that's actually what enabled us to also reduce a lot of the wiring. So that big snake-like harness you saw in the front is this harness.
Right.
It helped us get rid of it. And try lifting it, you'll get a sense of...
I remember when I was at the launch for Gen 2, just feeling some of the wire harnesses, and I was like, holy smokes. Thinking about a little wire like this doesn't think about like much.
That's right.
But when you add it all up,
it's huge.
It's wild.
Huge.
Yeah, absolutely. And taking weight out of the vehicle is one benefit, taking cost out is another benefit. But from my perspective, almost the biggest benefit of this is just the future, sort of future proofing that you have.
Exactly.
And it led to the Volkswagen joint venture situation.
Exactly.
So
exactly. And I think
that was huge.
The other piece that also is reliability. The fewer connections you have, the more reliable it is.
Yep.
Which is another side benefit people don't think about, but it's true.
Now, back when you were designing these ECUs, Rivian wasn't a thing. There was no right vehicle on the road. Were you kind of like, oh my gosh, if this doesn't work out, all this work into ECUs are going nowhere?
Our CEO, RJ, is a very optimistic man. So I don't think he thinks that way. And I think that gets everybody thinking the same way. I think when people are really excited about being able to work at this level, it motivates engineers to really, they're not giving a spec to somebody else. They're actually owning it the whole way through. So I think for a lot of people, it was a lot of fun.
Yeah, but this is also, you bring up an interesting point too. Like, this is the hard approach. This is not the easy way to go. The easy way to go is to call up a Bosch or a Magna or whoever and say, hey, we need XYZ, and then you guys package them. But to go in-house, do you know how this decision was made early on to really try and vertically integrate as much as possible?
That decision predates me and goes back to RJ. But my guess is if you go and look at a lot of successful companies in technology, they've really been using vertical integration, like Apple's one example, right? They go deep, deep, deep. And I think that's what you need to be really, one of our core aspects of our product offering is our technology leadership. We really pride ourselves on that. And you cannot be a technology leader if you're an integrator. You really need to bring value and differentiate. And I think that's, we believe technology is our differentiation. And by getting pieces off the shelf from other people, you lose that differentiation. Right?
Totally, totally. And I'll ask you just one last question because I know nothing about ECUs and electrical architecture. This is for the Gen 2 Rivians.
That's right.
How long do you think, or what would you, what does the next iteration look like? Obviously not asking you to disclose anything, but where could you go from here?
Absolutely. So, the thing I'll show you is these are our 3 zonal controllers. That's the south, and we have east and west. It's very simple, as you see. This is our infotainment and autonomy computer, the one thing that's liquid cooled. This is a battery management system. These two, we call them ECUs. So really, we say 7 ECUs. These are very tiny. This is sort of a vehicle access ultra wideband unit. This is our NFC detector. That's it, right?
Wow.
So we have a very simple framework now. And what we now do, where we go with this, is this forms the basis for R2. And it enables us to get R2 out much sooner. These units already exist for R2. In fact, what I realized is I forgot to show you our R2 card, but I will do that.
Okay, thank you.
But these units already exist. And, RJ's been posting videos of, I think, R2 little sneak previews. But they're already on their, second iteration is done. We're testing the vehicle. What it's really enabled us is to then focus on how do I cost reduce this, how do I optimize it, because R2 is at a much lower price point. But it helps us get going on R2. So this whole thing, just think of this as you iterate on this and do another version of this. And a lot of the heavy lift was done going from here to here.
Right.
So now we can really focus on making each one of this so much better.
Nice, really cool. That's what I love to hear. I mean, just to know that you have the framework for future models and also for the JV makes a lot of sense to me.
And so this work was not just to make Gen 2. It was also to build a platform that we can develop on and helps us get R2 out so much sooner.
Cool, amazing. Thanks for showing us this.
Yeah. And these are just exploded versions of these. So if you, different ways, these are the, Gen 1 ECUs. We also put our cameras in because these are, let's see, you're trying to see, I think they put the wrong set of cameras out for me, but that's okay. So we'll ignore that.
Yep.
But yeah, these are the ECUs here. We have these in exploded version out here. And
yeah, pretty amazing. Now, I'm not 100% sure what we're looking at here, so maybe you can even point out to our viewers, like, what specifically makes your PCBAs interesting and stuff like this. Obviously, a lot of it's down to the software control and your I/O, like you were mentioning. But is there anything unique that we're looking at that I should know about?
I would say, I think, we have, as I said, those, those big clunky fuses you saw there. Those fuses, just look at this box. I guess one of these, right, if you think about it.
Yep.
just look how big this is. It's almost, I would say half the size of this. That fusing capabilities is now here.
Just
right?
built in naturally.
Built into this, yeah.
Wow.
So that's pretty amazing. I'd say, just look at even the connectivity, right? When we integrated, these are what we call press fit pins.
Yep.
The thing about a zonal controller, it's got a lot of I/O, and so look at all the I/O here. You have to really co-design this with a harness. And if you buy somebody's off-the-shelf unit, it's really not tailored ideally for you. So what it really helps us get is the best design for our system.
Right, because you're developing the harness and the connection points and everything from the ground up for your specific needs.
Exactly.
Makes sense to me.
And so I think it's important to see, not only does it pack in a lot of functionality that was in multiple ECUs before, now it's all packed into one, but it's all of those things. It's the efficient wiring, it's the efficient connectivity, it's the removal of e-fuses, all sort of packed in here.
And the last question I have for you on this topic here is, right now Gen 2 still feels a little bit in its infancy of what's capable from a compute standpoint, and we'll talk to James and Wasim later on about that. But what would you say percentage-wise from what customers are driving today that you're stressing the system? It seems very little for what it's capable of.
So actually, these are the zonal controllers, right? And we actually designed, that's the other important thing about doing your own hardware, is we design it with headroom. So we design enough headroom so that that's the whole thing about a software-defined vehicle. Over time, you can keep adding features.
Yeah.
So the microprocessors are here not fully exploited as yet, and that enables us to do more over time. But that's actually a really good segue into, this is the infotainment computer, and it's super cool.
Literally.
I think one of the most, and it's, exactly. And so this side is the infotainment telematics side. This is the autonomy side.
And they sit on top of each other?
They sit on top. They sit on either side of what we call the cold plate.
Yep.
And as you can see, this one mates with this. You see these two, and they sit on top, and that's the thermal interface material. The other one goes on the other side. And this is a cold plate that has, you can see, water.
And that coolant loop is shared with the battery coolant loop, or is it a separate loop just for this?
We have, no, it's not dedicated. It's shared with other parts of the vehicle. So we have multiple coolant loops, but it's shared. Yep. It's not dedicated for this.
But this probably has a pretty wide temperature range that it could operate in.
This has a very wide temperature range, but we're able to control it pretty well.
Nice.
And I think what we just, all of these are, we use automotive grade parts that are actually rated to, handle a pretty wide temperature range. So this is the computer we're talking about, the autonomy computer. It's got dual NVIDIA Orin processors.
Yeah.
Really, probably one of the leading in terms of, TOPS capability.
Absolutely.
Yeah, we're not close to using all of it yet, and that's what, as we add more features, we really have the headroom.
And Gen 1 is totally different from this, essentially. But right now, I would say Gen 1's been holding up pretty well with Gen 2 in terms of feature count. And again, I know it's not totally your department, but we're eventually going to probably run out of Gen 1 capability before Gen 2.
There's time. I think we have time for that. But then this is built with headroom, so we can keep adding features. And James is a great person to talk to about that.
Yeah, well, certainly want to ask him a bunch about autonomy. Can't wait till we get to that portion as well. But this is really cool to see what everyone's software is running on.
And if you think about it, again, this is really very purpose-built, right? We look at it, we plan this together, we have single unit. You don't get that if you go, and that means it's better cost. Better cost is better for the customer. And sometimes it's actually better performance. For example, we have a board-to-board connector between these two, which means I can really optimize my connectivity between these and speak very quickly. I also have, as you can see, not just Ethernet between the two, but I have this connector that has high-speed data. So I can actually share a lot of data between my infotainment and ADAS. And that's also a very interesting line these days, because ADAS has all these cameras. Infotainment also looks at cameras and lets us really look at it as a unified system. And that's maybe one thing, when you asked about the difference as compared to traditional OEMs, is we can look at this vehicle really as like, the power we have is to look at it as one computer and a lot of sensors, because we own all the hardware and software. And so in a traditional system where you have a box and it has some I/O, that's built by supplier A and this is supplier B.
Sure.
You really cannot share the content between each other. They're sort of in their world.
Yeah, and then it's up to the automaker, I guess, to try to figure out a way to interface them.
That's right, and that doesn't usually work, right? Because nobody wants to share. Whereas here, the way we've designed it, all my camera inputs that come here, well, they can share the content.
Yeah, you've got all the data capability.
We have all the, and so that's just a very simple example of, And that extends all the way to our zonal computers in the right. So we don't, even though we have different computers, they're not boxed in that way. Even though they're physical boxes, they're not boxed in to only look at the content that they speak to. They can really look at the data. And so in a very simple world, which is what you want, where one computer, lots of sensors and actuators, and you really have access to all the information, you can actually build a much better design that way.
It just seems to make sense. Like if you're going to do it, this is the way to go. Why would you have, 50 different ECUs from a bunch of different suppliers and then try to make it all work? And we've seen, I know you can't comment on this, but I can say traditional automakers really struggle in the connected car, new age of electric vehicles. We get to drive everything. Our viewers know this. And man, it just seems like things move so slow. They don't get new updates. They don't improve. Whereas as a Rivian owner, my truck is completely different and better than the day I bought it. And even our Gen 2 vehicle, which we recently got, has improved massively through over-the-air updates like that.
Exactly.
And that is what's so cool. You don't have to call 50 different suppliers to validate everything. You can just do it right here.
Yep. So I'll give you another example, a GNSS, or GPS, right? Both navigation and infotainment need that information, and so does ADAS. In a world where they're two separate things, those systems you pay, the customer's paying extra money to have separate units. But we can very efficiently share that data between those two, right?
Yeah, so reducing part count as well and complexity. That's good.
That's right. And really having a very holistic view of the system, right?
Love it. Well, I'm really glad we got to separate all this out and get to show the viewers this. This is the stuff that is just a dream for me to be able to show everyone. And we saw some of this at the Gen 2 launch, but of course it was such a quick thing we didn't really get to dive into it. So thank you for exploding all of this out for us.
And then let me show you one thing. This is a quick and dirty place, but we talked about how we did thermal testing.
Yeah.
And we actually have, sort of like gigantic, almost warehouse-like rooms where we have big boxes where we put these and they're stress tested. But this is a quick and dirty tester, right?
Yeah, so we can go to the big room building too. That sounds fun.
But for example, here you can see it's a temperature chamber. You can control the temperature. You see one of our ECUs in here, and we stress tested. And then there'll be laptops connected to it, because they're monitoring the I/O and seeing how they're working. And so this, tied with the tester work we showed to you earlier, is a way we really make sure not only are we designing a design that's holistic, but it's reliable, it works across spec, and it's going to be with the customer for the duration of the time that they use it.
Yeah, and Rivians get used hard because they're designed to go off-road, and you have huge vibration loads that are going to go in. So I imagine even compared to like a typical, city economy urban car, you've got to go even hardcore with your testing.
Absolutely.
Because of the use case.
So we have very, very rigorous, load profiles that we really tested. Yeah.
Nice. Well, I think we've probably pushed the limits on those a couple times. So thanks for making sure everything works for us.
Thank you. Thank you.
Yeah, and thanks for showing us around the electrical architecture. I know we're going to meet with some of your colleagues, going forwards in this video, but really they wouldn't have anything to put their software on if it wasn't for your team.
That's right. It starts here.
Yeah,
so.
Amazing. Well, thanks for all the time, and thanks for the viewers to, hopefully we all learned something. I learned a ton. James, welcome back to the channel.
Yeah, great to see you, Carl.
Great to see you. So for those of you who don't know, James, you're basically responsible for like the driver assistance autonomy division within Rivian.
Yep, exactly. Yep.
And I think from what we've seen from Gen 1 to Gen 2 is a massive hardware improvement.
Yep.
With now we're starting to see that like extra feature count coming with hands-free enhanced. And so it's just, it was a kind of annoying for the first couple of years because I'm like, man, some other cars do some crazy stuff. And I'm like, I want you guys to get there. And now we're really seeing this massive improvement.
Yeah, team will be super happy to hear that. Like, I think we've been very hard at work. Gen 2 was a kind of a complete rewrite for us. So we kind of started from scratch, and we've been building the stack to really have that kind of higher ceiling, right? So we can take it to more autonomy levels, do more things, launch more features, things like hands-free. So.
And that's what I want to learn about today is the development process, because I think so many, especially EV enthusiasts and our viewers are, intimately familiar with some of the crazy advanced systems, both in China and North America for what's possible. Then looking at what you guys are doing and saying, yeah, you got the hardware there, you got the compute there, and what is the next step to get to really competing at that level with others?
Yeah, we want to be the best. I mean, that's why we're here. So
love to hear it.
Not there yet, but we're working on it.
All right. So we're kind of in a separate building. We were just with Vidya, your colleague, and so we're like on the other side of the building here. And there's a bunch of like camoed R1s. We've got some LiDAR stuff going on here. Now, you guys don't use LiDAR in your production vehicles.
No, we don't, but we do use it in our ground truth fleet. So
so tell us about this.
Yeah, so you see a bunch of these vehicles. We call them penguins. So the reason is The very first ones, they were all white R1Ts with a black roof. So
nice.
They kind of look like penguins. Anyway.
Love it. So if you ever see one of these, it's a penguin.
It's a penguin, yeah,
cool.
exactly.
Love it.
And so we've gone through several versions of these. I think this is like our version, this is like version 3, essentially.
Okay.
And so this has like completely representative cameras, radars that you would have on a production vehicle, but we've added LiDARs to the front and on the roof. That gives us that kind of ground truth ability, right? So you can label all the objects, you can pick out the lanes, it's like centimeter level precision, and then we use that to train the models that then run on board.
Yeah, so have seen spy shots of not just these cars, but even others from other automakers, running around, especially here in the Bay Area. And so, first of all, how many of these do you need? How many miles do you have to run in them to feel comfortable? Like, I guess I don't even understand the use or need. Obviously, you mentioned labeling and things. But maybe you can give us a little bit more industry background on what happens with these penguins.
Yeah, so the diversity is super important. So we actually, the penguins you see here, there's probably more than double actually out driving, often doing cross-country missions.
Great,
so
sign me up.
we've been...
Throw one on my truck.
Yeah, so we did a mission in Vancouver. There's a vehicle right now in Miami driving around. And so the idea is to just get as much diversity of road types, objects, scenarios, weather as possible. And then that makes the models very, very, capable, robust, and reliable. Because obviously if you're only driving here in sunny California, you're never going to see a snowstorm. You're never going to see, heavy rain.
Of course, it doesn't help you too much. But why LiDAR? Why do you need to do this? Can't you just buy HD mapping data? Like what? I guess.
So HD mapping, can help for lanes, although it's often, inaccurate. But obviously for objects, right? Objects, they're dynamic. They change all the time. The LiDAR essentially, when you look at it in the top down, it almost you can kind of draw a box around it, and that's exactly what we do. So we send that to be labeled. We draw boxes around those. That gives us the training data. Yeah. And then we use that to train the onboard perception model.
Is there ever
the brain of the car?
Is there ever a future where you won't need to do this, and you're going to be confident enough with your own sensor suite to do the labeling side? Obviously, the vehicles are relying on the sensor suite. I didn't mean to say that you're not confident in it, but you know what I mean. Where this step might become unnecessary.
Yeah. So in parallel, we're also working on an auto labeling step, and that actually could take a camera radar rig and auto-label those things. And the way you do that is you can aggregate the information over time, and then you can kind of align it, right? So, and using that, together with some of the models that we've trained from LiDAR, you can actually get labels. I still think you'd always need a certain number of vehicles doing this type of LiDAR work, but over time, I think you can train more and more just from the customer data.
Amazing. And so I can just see a row of Rivians. Now, these aren't all yours. This is kind of a shared.
Yeah, this is a shared pool. Yeah, so on the weekends, engineers normally are taking out one of these cars, testing new features. This is how we get a lot of our early feedback before things go for a wider kind of validation.
And I guess back on the Penguin data, can we show the inside of what these things look like? Can we show some of that?
I think that's fine. Yeah.
Cool. Yeah, because I got to see inside of one of these, and dude, you've got these things sensored up like crazy. So Jordan, if you can show these two cars over here. These are both Gen 2 Penguins, I guess.
Yes, exactly. Yeah, Gen 2 Penguins. I think we've got the door open on this one. So the thing about these data collection vehicles is you're collecting a lot more data than you ever would normally, right? You actually sort of have continuous logging. So you need a big set of hard disks and computers to ingest all that information.
Yeah, and how do you choose what you take versus not take? I mean, obviously you don't want all the data because it would just get too large, or are you literally taking as much as possible?
So here we're basically logging everything. Now, when it gets to the cloud, now you can sort of pick what's interesting and what's not. And actually, I don't know if you can see, there's a touch screen there, and the drivers, they have a number of options. So you can pick, I saw an interesting scenario, I saw a dog running across the road, and there's a button you can press. That data is then useful when we're picking what to train on.
So you'd say you probably have 10 or 15 of these running around at any given time?
Yeah, I think there's about 10 that are sort of based around here, and about 10 that are doing sort of cross-country missions at any given time.
So currently, Rivians have, I would say, a fairly limited driver assistance window as to where it will let you operate. First of all, it needs to be on a closed access highway. You've added a new feature of enhanced highway assist, which is remove your hands, and it's eye tracking, and that worked great. I used that on my 1,000-mile trip recently. Really it is funny that it doesn't actually give you back any more time just to remove your hands, but it feels great. There's just something nice about not having to touch the wheel all the time. And the eye tracking, I thought, was the perfect level of safety and intrusiveness. You don't want to go insane, but you obviously need to make sure people are watching the road with today's.
That was a lot of tuning to get that just right. Not be too naggy, but also not be too permissive. Right, just getting that exactly right.
I thought it was a really nice balance, which I'm normally complaining about all those systems. It really didn't bug us much.
Great.
But what about the future? Because we're looking at, not to name anyone in particular, Tesla, but we're looking at others that are just driving me around. I don't have to touch anything. What's the process from here to there?
Yeah, so I think it starts with great perception of the road, right? So obviously we can't drive anywhere where we don't really understand the road, understand traffic control, understand lanes. And so actually this is kind of the starting point, right? Getting all that data, not just on highways, but in urban areas, off highway, suburban areas. Once our perception models are good enough, the team is actually over in 660 training them right now.
Great.
And we have the confidence, then yes, we can start opening up the ODD.
Nice.
The maps is essentially it's a crux, for a perception system that's not yet capable enough.
Sure.
But over time, we're going to open that up.
I'd love to hear that.
Yeah.
That's amazing.
Yeah.
That's super cool. So as we walk inside here, Jordan, if you actually, it's a little bit odd, but run in front of us if you don't mind, Jordan. This is like your workshop area.
Yeah, so this is the ADAS garage. So the team, we build all of the penguins here in this shop.
Cool. So are these future penguins then?
These are just Gen 2s, and they'll have various different types of software running on them. So we use
and how many versions ahead do you live from what the consumers are driving?
It varies. So sometimes we might be one release ahead. Sometimes we might be actually testing a feature that may be 6 months or even a year out.
Oh, okay. Very cool.
So yeah, it really depends on the feature. Yeah.
So this looks somewhat familiar to me. I was just in your factory this week where every car kind of gets aligned and moved around. And we talked a little bit earlier about some auto alignment stuff. So I thought one thing that was interesting, and I hate to keep bringing it up, but as someone who spent a lot of time driving Tesla vehicles, previously you'd have to drive them 10, 15, 20 miles,
right.
When you first took delivery, calibrate the cameras. Now they're even speeding that up to do it in the factory line.
Even shorter, yeah.
Yeah. So what does that look like for Rivian? Because I think not only is that beneficial, just to have that tech, but also like if you've got to replace a windshield or something.
Yeah, absolutely. So yeah, I mean, it's especially important on Gen 2 where we have 11 cameras now. So if they're all pointing this way and that, it actually isn't very helpful. So calibration is super important, knowing where cameras are pointed, how they're related to each other, and also to the radars and to the vehicle. Those are all very important things. So yeah, this mimics the calibration setup we have in normal. So we drive vehicles in. There are stops here that kind of align the wheels. Mm-hmm. And then these targets, we've essentially surveyed them. So we know kind of the true location. And then we use a bunch of linear algebra to basically solve for where the cameras are pointing.
Amazing. And then this sort of cone-shaped one is for the radar.
Yeah, so that's a radar calibration. Yeah.
And what is your impression on the, before we get into software, and maybe you can tell, actually, I'd love to hear if you think I'm right or wrong on this.
Right.
I've driven now a bunch of Chinese driver assistance systems and American systems, and the Germans, of course. Every automaker seems to say, okay, we're going to go camera only with nothing else. Mm-hmm. Some say we're going to go camera and radar, which is sort of your camp.
Yep.
And then some say, let's throw everything we possibly can, LiDAR, camera, radar, plus fusion, all that stuff.
Yep.
From my impression, it almost seems like the hardware doesn't make much of a difference. It's about the software behind it. It determines how the vehicle drives. But can you get all the way there with what you're using, do you think?
So I think you have to distinguish, maybe how a demo feels from how the very long tail edge cases handle, right? Mm-hmm. So, especially in those higher levels of autonomy, you really want the system to not just feel good over a couple of hour drive, right? Yeah. But over hundreds of thousands of miles. So that's a very high bar. And, sometimes you hear humans don't have lasers shooting out of their eyes or radars coming out their ears. But I think for us, the goal is not human level, but superhuman level, right? Especially on the safety side. Mm-hmm. And so those sensors really help with that. I think they can make the system more robust. They can speed up development because now your perception is just that much better. And then the things on top of that, they can develop faster.
Oh, that's good.
So I'm a believer in sensors as long as the price is right. It's well integrated into the vehicle. So I think we've found a good balance here between.
Yeah, I would agree. We just did a video the other day, and I was saying the same thing. That's just my outside looking in approach.
Right.
But I of course hear everyone's different opinions. But it's great to know where you're coming from on that.
Yeah, for sure. Yeah.
And so, would you say, right now, if someone goes and buys a Gen 2 R1, what do you think that vehicle long term is really capable of doing from a functional standpoint?
Yeah, so we're working on opening up significantly more highways this year. So opening up that hands-free sort of highway assist experience. We're also looking at sort of an eyes-off feature next year. We're trying to figure out exactly how to do that, but
might be one of the first kind of to do.
Yeah, I think there are ways of doing it. So that would be exciting. And then I think longer term, really imagining a system that's, incredibly capable, driving more and more, able to sort of meet drivers where they want the autonomy to be, right? Also looking at parking, we think, automated parking. And then sort of over the very long term, we think there's a number of sort of personal L4 use cases. So, imagine getting to the airport, jump out of the car, and it just goes off and parks in the long term.
Could use that today.
Spot. There you go.
Amazing.
So not really thinking about like robotaxis, but I think for a personally owned vehicle, there's a lot of features and interesting things that can make the experience great.
And Gen 2
safer.
can kind of handle that.
Yes.
Okay, good to hear. That's why I was really curious about the long-term stuff.
Yeah.
So my understanding is we're going to go for a drive today?
Yes. Yep.
So what are we going to experience during that?
So you're going to see a feature, you're going to try a feature that I don't know if we've named it yet.
You would call it collaborative steering.
Yeah.
Collaborative steering? Okay.
I think it will have a different name when we launch it.
Yeah.
So with collaborative steering is a really interesting feature for us because you don't need it to make a safe car. You need it to make a comfortable car, right? And so especially with the autonomy that customers have, one bar we set for ourselves that's super high is that people can always choose to drive the car themselves. Yeah. So by turning on the feature, they've actually chosen autonomy over the active, sort of driving of the car, right? And so with collaborative steering, I think there are two things that we're really excited by, and we'll pick a new name. But this one is we really want people to feel like they have some control, that we can actually adjust it's almost as if your caster and alignment is dynamic, and the car will naturally kind of magnetize to the lane center, and the car will follow. But you can make adjustments, but you can feel the car almost as you're going off center that it will still want to follow the lane. So it's like a really like natural feeling, collaborative steering feeling. And then as James said, like as we get more into like really like building these emergent behaviors from the system, knowing how humans drive naturalistically allows us to build a more natural system ourselves. And so really for us, it's like, it has to be, like you see it everywhere in the car. Like it has to be not just, it can't just work, it has to be great. And so and this is a big piece of aiming for great. You care about like having these cars work well everywhere.
Yeah,
and you saw the
like in the I-70 climbs, like you want that thing to rocket up there.
Oh yeah, we look at that. So I think just like making sure that we have a great system that gets better over time, but you're noticing this now. Yeah. I think I'm super excited for the rest of the year. So
viewers, you join me out on 280 near your office.
Yep.
And we are cruising in a nice Gen 2 tri-motor. Oh, I just activated enhanced highway assist by accident there. So let's can we start with that feature really quick? The enhanced system?
Absolutely, yeah.
So a lot of our viewers may not know this. We have a whole video that just went up before this one went up, explaining how this works, and we used it for a trip. But there's a little icon in the instrument cluster that was there a second ago, but it does come and go at times. And essentially it will indicate when it's ready for me to remove my hands from the wheel. So I got to have my eyes forward. Then it says, remove your hands, and boom, enhanced highway assist on, keep your eyes on the road. Now it's actually a hands-free eye tracking system.
Yep, absolutely.
And let's not get too much into this because we'll explain it in our hogback test, which is going. But you've got a new thing for us to experience, which is this sort of collaborative steering where, a lot of systems, if you try to input steering into a wheel, just breaks away.
Yeah, so the current behavior of highway assist today is if you move the wheel, we drop back down to ACC actually. Now we get a lot of feedback from people that are like, when there's a big rig next to me, I really want to nudge a little bit over, or if there's a wall right next to the road and there's no margin, then I want to nudge a bit over.
Or potholes or anything. Really,
So really, so we introduced this feature, collaborative steering, and that actually allows you to nudge using the wheel. We spent a lot of time on the feel of this, so we really wanted it to be not like you can steer anywhere, but more like you're sort of being magnetically attracted within the lane.
So it'll always try to recenter.
Exactly, yeah. So you'll feel a little bit of pull back.
And so I can try that now?
You can try that now.
Okay, I'm just making sure no one's to the left. But
so you can.
And that's over. Really nice. It's not breaking away.
No.
A lot of times, what would break away? Scott, who works for us, just got an R1S, and she would, we'd be next to a truck, and she would put some steering in, and we'd go, whoa!
And then you brake, right?
Yeah. And I'm like, okay, let's work on that.
Yeah.
And here you can just very nicely move it to the left side of the lane. I can feel it building up pressure.
Yeah, you just start to feel a little bit of kind of back pressure as you get towards the line.
Yeah, that's awesome.
Yeah.
Really nice.
Feels like kind of bumpers, right? Like casters.
Yeah, you've got your guardrails.
Yeah.
And you can kind of move around, and it always wants to be in the center, but like here, just to move a little bit to the inside.
Yeah.
Super nice, and it just builds up that pressure right on the end and pushes you, when you hit that line.
Yep.
Dude, this is nice.
Yeah,
and
cool.
the feeling is perfect, like you were saying. I'm sure it took some tuning.
Yes, a lot of tuning.
Yeah, so we'll just do a quick auto lane change here. So it's doing that nicely. Oh.
It did on a board there because this car is coming up kind of hot behind you.
Yeah, that's smart.
Yeah.
So we'll go for another auto lane change once there's room. Yeah. But I thought that was smart because he was pretty far away and then was ripping up.
Okay.
Nice.
Yeah, so actually the lane change, we're using that full perception system trained from the Penguin fleet, and it's reasoning all the time. So if there's a car coming up, fast in the lane next to you, we will actually abort that lane change, bring you back, and then it will attempt to recomplete it after the vehicle's passed. So
super nice. And what I'll probably do is take the next off ramp to rip around and head back. But just want to get it on this straight bit of road right here, just to totally show the viewers one last time. For example, if we're here and we're got a pothole up ahead or whatever it is, I can just nudge us right over here. Now we're hugging that left side of the lane. I can hold it there. I do want to get all the way through, and it just keeps pushing you back.
Yep.
Super nice. Love this feature. This is super cool. Really, really thrilled to have this. I think if we had this for our road trip from normal, it would have made all the difference in the world. Yeah, so thanks for working on this.
Yeah, of course. Yeah. And then the other nice thing about this feature is over time we're learning where and when people like to nudge and by how much. And that actually we can feed that into the models, and then over time the system gets better and better. So nice.
Also, CT5V Blackwing. Great car. We love it. All right, so thanks for letting me demo this.
Yeah, of course.
And we'll see you guys back at the building. Guys, I'm with my friend Wasim. Welcome back to the channel.
Kyle, how are you?
This is the man at Rivian that is responsible for so many cool experiences that your customers and our viewers get to have. So maybe you can share a little bit just about what you've been doing at Rivian, maybe a little bit with the JV, because you've been involved really at the highest level here.
Kyle, are we doing the
out of spec pose?
Awesome. We're super excited to have you, Kyle, here with us in Palo Alto. This is where the magic happens. This is where we build our software, our electrical hardware. Personally, for those who don't know me, my name is Wasim. I've been at Rivian since more than 5 years now, which is an eternity in Rivian years, but it's been a fantastic experience because I had the chance to build the software stack from the ground up. And then I think most importantly, what I'm really proud of is building the team that made this happen. And you'll see that today, the team in 2 years managed to get the R1 Gen 1 to the market, going really from a clean sheet stack approach. And then we did the full migration to Gen 2. And Gen 2, God, you're a customer of Gen 2. Gen 2, it's really changing the guts of the vehicle. On the outside, it looks pretty much the same, but then a ton of things have changed on the inside. It's a completely different software stack. The electronics are completely different. I mean, we'll see some of that today. But it's a game changer for the company because this is, we're getting the fruits of that vertical integration, and then we're able, through that consolidation, to deliver actually better functionalities for our customers, but then at the same time have lower BOM cost, have better design for manufacturing, have better serviceability of our cars. And now, I mean, as you mentioned, since November, I'm also the co-CEO of the joint venture with VW Group, which is another exciting milestone for Rivian as a whole, because we're taking that technology and then we're getting that into a much broader set of products. And the reason we joined Rivian is to make EVs accessible to more people, and it's really in the heart of our mission to bring such capabilities, such technologies into many, many, many more cars. And I think for us, it's a fantastic opportunity to get that incredible scale that the VW Group has. So
Amazing. Well, thank you so much for sharing that. I mean, for those really at home, I'm sure most of our viewers know who you are because you're so active online as well. And so we love that you're engaging with the community and taking everyone's feedback. I mean, you've made sure that a lot of our requests have made their way into the vehicles. And so to me, Wasim is just the man in the whole auto industry, not just at Rivian. So yeah, I'm glad that we get to get you back on camera again.
Thank you, Carl. And we have some surprises for you today.
Okay. What? So yeah, maybe we can explain. What are we even going to see today? What's going to happen?
Okay. So we're starting first. We'll show you the behind the scenes of how we develop our electronics, how we develop our software. So that's more, as I said, the nerdy presentation of what happens, so that we can get all those regular updates to our customers. We can update our architecture. But then we also have 2 great demos for you. We'll show you later what we call the Energy app. This is a project we have been working on with a lot of passion since many months now, which is really what we're trying to solve is how can we demystify electric vehicles to non-prior EV owners? How can we make the energy experience, whether it's charging experience or the energy out, where your energy is going, how do we make that easy? Many of us are nerds.
Our viewers too.
Your viewers are.
Yeah.
But then we need to get many more people into EVs. So
yes.
How do we make that as easy as possible to understand? This is our first attempt. Would love to get your feedback later on.
Yeah, I'm actually going to take a vehicle on a road trip after this, 1,200 miles or so, with the new Energy app. And so by the time this video goes live, hopefully it's live in other cars, or it's all going to be coordinated somehow. But I'm going to test it out. So head to our motoring channel for a road trip with the new Energy app, because that'll be I don't know, live, hopefully by the time this one goes up.
Awesome. And then we'll have another surprise for you. Something you actually requested.
Oh, okay. I have no idea what it is.
Your pain point for the dual motors. So we have an attempt on how we will fix that.
Nice, because you also have to fit within EPA regulations for that a little bit. So
we'll show you how hard that is. But we have a solution for you.
Great, thank you. So, okay, nerd stuff first.
All right.
This is your world now. Because,
Yes.
you know, you're probably sitting in meetings all day long. You want to be playing around with this stuff. You know, what are we looking at here?
This is what we love the most. So, this is what we call a hardware in the loop system. So, think about it as this is actually an entire car, pretty much, but then in a rack.
So, all of the ECUs, sensors.
All the ECUs, primary ECUs, and then secondary ECUs, and then the main sensors. And then just like if we look at super high level, I mean, for example, this is a Gen 1 car. And you can see how busy that is with all the ECUs. I mean, for example, I have here what we call a BCM. So a BCM stands for a body control module. And the way the architecture of Gen 1 was, this is what we call a domain architecture. So think about it as a big feature functional domain has a controller, which obviously resulted in lots of controllers throughout the car. Now, the way we designed Gen 2, if I look at our friends here, you already see it's much cleaner. And what I have here, I no longer have those names like BCM or CGM, which is, okay, this is a core gateway module. This is a body control module. This is a thermal management module. What I have here is EZC. So this stands for East Zone Control. And instead of having dedicated controllers which perform just one function, what we have is more general purpose controllers which perform many functions at the same time. So what that means is the only way, the decision we will make is where should we place those controllers. So in this case, we have the east, and actually we have the east-west controller and then the south controller. These are the three main controllers in Gen 2.
Yeah, and we showed those on the Buck somewhere, or
with the lab car.
Yeah, with the lab car. That's right.
Rivian,
Yeah.
sure.
Yeah.
And then what that drives and what that allows us, that completely reshapes what we call the network architecture of the vehicle, because that impacts everything. That makes our harnessing way cleaner. We reduced more than 1.7 miles, I think, of harness between Gen 1 and Gen 2. It also reduces mass. It helps us with cost. But then the great benefit for us is in lots of cases, we actually got rid of many of the secondary ECUs. And this is really like the move from functional to zonal is one of the fundamental changes in the automotive industry. I mean, the old world, if I look at that old world, the traditional world is, think about it as if you want a feature, you go get a controller. So if I want a door feature, then I get a door controller. Right. If I want the seat feature, I'll get a seat controller. In this new world, which is zonal, actually, there's no door controller, there's no seat controller. All we have is sensors and actuators, and then the entire intelligence is in units like this. So you look at our zonal controllers, this is where, like in this case, the control of the doors and then the seats is actually split between the east and the west controllers based on the placement. So the left door and then the rear door would have different controllers. And why is that beneficial? I mean, we talked about the reduction in terms of harness, we talked about the reduction in terms of mass, but we're removing one controller, so that's less cost, instead of having that go like to a stacked chain of suppliers. But then it also, it makes a cleaner packaging in the car, but then it also gives us way more agility in terms of how we manage the development in the car, because instead of relying in some cases on a third party to develop that small controller, we just do it ourselves. And like with the fantastic team that we have, hardware and software, we're able to iterate way faster in our development, because I mean, this is what we call in the industry vertical integration, which is really managing the entire stack from the bottom, which is the hardware, to the applications. And then everything in the vehicle is over-the-air updatable. And this is how we're able to continue maintaining that pace of development through the life of the product, and really like create that connection with our customers where the car is no longer static. The car continues to improve over time.
And you've proven that too. I mean, a lot of automakers will say, okay, we support over-the-air updates or we do X, Y, Z, but literally every month, my Rivian, I have a very early one and we have a newer one, they just get better and better. It's crazy. It's really cool. And like, okay, for a lot of EV owners, maybe that's normal, but so many automakers are not on that level yet.
And it's hard to do it. Like, if you really want to do it well, you cannot have your destiny within the hands of many suppliers for these small parts. So this is why that whole vertical integration, that in-house development allows us to go not only cheaper, but then go much faster. And then like, that's how we're able to also get feedback and then act on the feedback, because like we control our destiny. Like the way we would, let's say hypothetically, just expanding on the doors and the seats. Let's say we want to change the lighting animation, or we want to change the sequence of how we get to the car. In the traditional world, what you would do is, okay, you have people who are supplier management. They would go write a detailed RFP and then tens of lines in an Excel sheet, and then they would be managing a supplier and negotiating an SOW, and then commercials in sometimes millions of dollars.
Yeah.
And then months of development, and then you get the functionality from the supplier and you start integrating it. Generally, sometimes it doesn't work, but then when you get it to work, you realize, my God, actually, this is not what I really wanted.
Yeah.
So what if we change it? If you want to change it, then how about another RFP, another SOW?
Yeah, another couple $100,000 or $1 million and time, and yeah.
And in the meantime, your customers already move to something else. So if you want to keep that pace of innovation, you really need control what makes your vehicle smart, which is your hardware and your software.
Yeah, so we met with Vidya earlier. We talked about, okay, Gen 1 still was a lot of in-house controllers, I mean, but not in the zonal sense. But maybe you can shed a little bit of light to our viewers. Obviously, Gen 1 and Gen 2 have a very similar feature set today. They've been on similar software tracks, but they probably operate totally differently.
It's actually a very different operating system. And that's like, I know in lots of cases where like we release features for Gen 1 and Gen 2, like sometimes we have Gen 2 customers not happy because it's Gen 1 only. Sometimes Gen 1 customers not happy because it's Gen 2 only. I do my best to get them at the same time, but it's not always easy because the underlying architecture is really different. And that's like what Gen 2 really brings, which is Gen 2, think about it as we removed that hardware complexity. We simplified the hardware, but then we kept the same feature set, or actually we improved the feature set. So that complexity is moving to the software.
Right.
So the way the software handles the interactions is actually quite different. Now, in the way we architected this, the team did a fantastic job so that I mean, like here we're going really into the weeds of software, but we have a ton of abstraction.
That's why we came to see you.
We have a ton of abstraction layers where we keep the applications as similar as possible. We developed our own operating system so that we can interact with the hardware in a different way. But it's a lot of work, and then it's a lot of integration and testing effort, which is needed so that we continue to have those updates at the same time. And really, like the way we see things, like our commitment to our customers is as long as the hardware supports it,
you'll add it.
We'll add it.
Yeah, like the Go chime came to Gen 1. No one expected that. That was really cool. Even just, you know, getting cameras on the screen, little stuff that's been really nice, just maxing out what that thing can do. But eventually you will reach a limit as to what Gen 1 can handle. And we're kind of almost getting there, especially from an autonomy standpoint.
Autonomy is really, I think, like that's the key area where Gen 2 has way bigger capabilities than Gen 1. And you're right. We're very close to the limit for Gen 1, and this is why a lot of our features on autonomy are really going to Gen 2. The actual stack itself and even the approach for autonomy on Gen 2 is very different. The Gen 2 autonomy is an end-to-end AI stack, which is developed in-house. I mean, I know you had lots of fun today with James and team.
Yep.
And that's a very different approach to the stack than what we have on Gen 1. So this is why, like on everything autonomy, we'll see like a big acceleration in the features for Gen 2.
Can't wait. That's why we got one, so we can film it and play around with it. It's amazing. So this is, you know, you're operating across multiple different ideas, VW stuff, Rivian stuff, the collaboration, but this is like your office. This is home for you.
My office is actually like 3 meters away. Like this is our playground. This is one of our labs. Think about these. This is hardware in the loop. We have probably dozens of these representing each of the cars. And actually, let me talk about how we use them.
Yeah, please.
So, like if we go to this, for example, this one, which has a test session which is ongoing, and you see here it's doing an OTA update. What's really great about these environments is that it allows us to test all the platform aspects that make the overall software stack robust. When you think about it, people get what they see from software is generally the UI.
Yes.
This is the visual elements, but that's not the hard thing to do in software. What's really hard is the underlying, how can I talk to the hardware? How can I make things work? And this is one of the environments which allow us to have a head start and really a predictable way so that we can interact with the hardware. And like, let's talk, for example, about a feature like over-the-air update.
Yep.
The challenge with over-the-air update is that like every time we do an OTA now on a monthly basis with Rivian, we're talking 150 plus cars. So you could say, yeah, 1% 99% of pass rate is great, but then the challenge is if you have 1% of failure, this is 1,000 unhappy customers.
Absolutely.
So we cannot afford that. So the way we can get ahead of that is that OTA cycle, we need to test it thousands of times with such automation racks. And what these automation racks provide us is a way to not only get things like repeated, so that we go through all those issues in terms of, say, weird timings between the ECUs, how they communicate with each other, but we can, because we can instrument the entire environment, we can come and inject faults to the system. And actually, a lot of what we do in software is, and that's the beauty of our vertical integration, is our goal is as possible to make the system available for the driver. So you see sometimes all these weird notifications, all these diagnostic codes, and what the software is doing behind the scenes is trying as best as possible to keep things up.
Right. Its goal is to make the car drivable.
It's always make the car drivable. And number one goal is safety. That's above everything. So like we have a number of reactions where we escalate what we call the safety reactions. And then the goal is, okay, if I need to react to an event, how can I make it in a way where customers don't even see it? Then if, for example, I know that there's potentially a mechanical problem, okay, how can I degrade things but then go to limp mode?
Yep.
So still the customer can drive the car, but then in safe conditions. If limp mode is not possible, then how can I get the customer to a safe place so that from there they can either reset the car or we can have an emergency reaction? So all that logic is in all these safety critical systems that we have. And what these systems, what these test assets allow us is to come here and inject some of these faults.
Right. So you can simulate, okay, whatever, a crash happened or, a sensor failure or a motor failure or whatever it might be. That's pretty cool.
Or I have, as an input, I have a battery issue, or I have a thermal issue, or I have one of my crash systems. How do I get the entire stack to react in the limited time that we have?
Sure.
Because for each of those use cases, we need to accomplish requirements where, okay, we have a certain time of reaction so that, okay, we get the doors to unlock. We trigger automatically an emergency call from the vehicle so that we call our emergency provider. We open the contractors.
Yep.
Because so that we can get the vehicle to a safe state from a high voltage battery standpoint. We keep the low voltage for a certain time. We collect data, we collect logs so that we can use that, one, for the customer from an insurance standpoint, two, we use it for us in terms of continuous improvement of the system to check if we reacted the right way. And all those type of test cases, these environments allow us to do what we call fault injection and really make sure that as we continue to update the software does behave the right way.
And have you ever found use cases from customer vehicles? Because crazy stuff happens in the wild, that you are now injecting some of those cases into these tests?
100%. I'll actually show you later on some of that in another test environment.
Cool.
But that's really the beauty of like the connected car architecture that we have. When you think about our car, you think about what's in the car, the embedded systems. Like sometimes I tell my team that actually the cloud is even more important because every single Rivian has connection to the cloud, and then there's a number of signals in terms of reliability that we collect, and then that allows us to get data that help us to improve the reliability of the car. All those tricky scenarios where we see whether our systems reacted the right way, and in some cases, there's corner cases that we did not necessarily think about.
Sure.
And that is really what triggers that continuous improvement system where, okay, we rethink how we should react to some of these instances. And that's like the beauty of what we're doing is with the level of visibility that we have on what happens in the field, and we start to have now a ton of miles with Rivian cars, that trigger really that virtuous improvement. And one of the things that I'm really like super proud of what we did with the team last year is we had a case, I mean, this is public, we had a case of, there was a case where we had a recall because of accelerator pedal.
Yeah, the sensors or something in there, yeah.
So the way we found this, I'll give you the full story.
Yeah.
So the way we found this, one of the customers reached out to service team and said, the way the axle pedal is behaving is really weird. We train our service team so that when they get inputs which are related to safety, I mean, there's some red flags, they need to inform engineering immediately.
Yeah.
And we get the call from service saying acceleration issue. That's like the nightmare for.
Yeah, but that's also really cool because like if you have a traditional OE, you go through a dealer process 100%. And then the dealer goes to like the area manager and then it never makes its way 100%. Back to engineering. Yeah.
That's really the beauty of that direct to consumer model that we have.
Yeah.
Which is immediately my team got the ping from the service team.
Amazing.
And then, okay, task force, everybody, like the nightmare for every OEM is an acceleration issue.
Sure.
We get the input, okay, it was less severe than what we thought, so okay, everything is under control, but it still doesn't make sense. Mm-hmm. We analyzed the data, and then we realized that the axle pedal was not behaving the way it should be. There was a small gap. It's still within some level of the spec, but then there was a gap which was unexpected. We checked the data, because we are also not only I mean, we have direct to service, but then we have our own manufacturing, our own supply chain. First of all, we checked the logs through the cloud. Then we looked at the entire fleet to see if there's other cars which have similar deviation pattern. And we identified that there was probably other, let's say, a couple of dozen cars that had similar behavior. Then, okay, we have an issue. We take the data of the VINs. We could correlate exactly that from our data platform, we could correlate that they actually came from the same lot in manufacturing from the supplier.
Wow. Yeah. So you trashed it back, backed it up all the way to that batch of accelerator pedals.
So we knew when we actually received that batch from the suppliers, then the question is, okay, now the cars which are impacted are in few digit thousands. What should we do? Traditional OEM would say, okay, immediate, basically we'll need to do a recall, but then the only way to solve it is you need to get your car to a dealership and then we will replace the axle pedal.
Right.
The beauty here is the team, our goal is really minimize that customer friction. I mean, recalls may happen, but if that happens, we want to deliver the best experience to our customers. We don't want them to have that pain.
Yeah.
We want to make it easy for them. So the team, by looking at those data and the pattern, came up with a completely creative idea where they understood exactly how is actually the drift was happening in certain temperatures.
Ah, okay.
So it wasn't happening in all nominal conditions. And we could actually identify not only the batch where this is happening, but then the temperature conditions. And then we could apply a software correction to correct the drift.
Amazing.
And the team was able to get an OTA out in, actually, I recall this really well, in 4 days.
Wow.
And then like that fixed immediately the issue in the field. I mean, we still had the customers over time come and replace the axle.
But it took the safety risk out immediately.
But we took the safety risk from our customers.
Okay, that's amazing. I mean, very few, maybe like 2 or 3 automakers on the planet could do a 4-day fix like that.
100%.
Yeah, almost no one.
But like to do that, obviously you need to have this vertical integration, you need to have this hardware and software, but then you need to have this connected car architecture, but then you need to have a great team. and I mean, you met
it's the
some of
perfect
them.
storm. Oh yeah, I've met every colleague of yours that I met. They're an enthusiast. They're super smart. They're with the program, and it is like everyone's very passionate about this. I wanted to ask you, we mentioned some safety and emergency stuff, but the other thing I really need to commend your team on is the ability to innovate and like add features so fast. So for example, last summer we made a video when we had the dogs on a road trip. I don't remember the exact scenario, but I remember thinking dog mode didn't cool down the cabin enough. The rear air vents weren't on, and we just wanted the temperature cooler. And in like 8 weeks or less, you had, boom, updated dog mode for Walter. So thank you for that.
and actually, we did a shootout to Walter. I mean, and honestly, this is what I love about what we do. And I think a lot of people would tell you, I really think this is what makes Rivian special. It's really that relationship that we created with our customers. I mean, we're very humble, and we feel like, personally, I really believe that our customers are part of the journey with us. Our goal is to deliver the best possible product, but then our customers are part of getting that feedback and helping us make a better product. I mean, Kyle, you did lots of videos where,
especially early on,
where with fantastic feedback, and when we did things wrong, you have been fair with us, and you told us that we were wrong, and that's exactly what we need and what we want to have from our customers. And like deeply, we are a team and a company who believes in continuous improvement, and our goal is to continue to make that product better and better.
But that's why I drive my Rivian every day, and more than any other car that we have. Even when we have cars on test, I drive my R1T around, because it is like, wow, I also feel like our videos and our viewers, and it's not just us, but it's also the people, like I saw you gave a shout out to another member in the recent software update. Like, that is so cool, and no one else does that. So maybe you can explain a little bit on that process. Let's say you're on Reddit, you're Mr. Reddit over here. So let's say you're on Twitter or X or Reddit, and you see a great idea and you want to incorporate it. How long does it take you to, let's say a basic idea, to go from that to test it through here and into the car? What's that process?
The answer is it depends. It really depends on the feature, because the complexity of what we do in automotive is, like, a car is a very complex system of systems. And there's really a lot of difference between, say, doing a feature which is infotainment only, and impacts the UI, and then having a feature which may touch the safety critical systems, which need to go through much more regular testing, or having features, for example, which touch homologation. We'll talk later about some of the range related features. For example, every time we may change something related to range, that has a cycle, its own cycle in terms of development and validation. So the answer depends, but generally the way it works is, I mean, we're constantly on the hunt for that feedback, and like what we appreciate is that open relationship where our customers are very open with us when it works and also when it doesn't work.
You'll get it all. But what's cool is you actually receive the feedback. So many times our feedback and our viewers and just customers, it just goes into the ether, and it never ends up with, and you're literally the man in charge and the man getting everything going. Do we need to speed it up? Yeah, okay. Anyway, thanks for everything. We're going to keep moving. But
all right, let's, we'll probably close on this, and then we'll keep moving. But really the prioritization, it's an art. It's a fine balance. And then it's based on, like, without also going into the weeds of product management, it's like, okay, the impact to the customer and then the complexity of development. And let's say the feature which has the biggest impact to the customer experience and the lowest complexity of development, the lowest effort, like, it wins.
Yep.
The feature which is just for like niche customers, it's a very rare use case, but then it requires a ton of development.
Yeah, probably gets pushed back.
And then it's a regular prioritization. And because it's our own team, because we control our destiny, because, as you said, we like hear the customer directly, so like there's really no middleman in the entire process, we get that feedback directly, and we get it through that regular machine of prioritization. And if we feel that, okay, summer is coming now, I know you have feedback on keep cool.
Keep climbing on.
Keep climbing on.
Yeah.
So that's one of the features, for example, that, okay, we know that feature will really make our customers' experience better in the summer. So it's getting in the prioritization queue.
Makes sense. Amazing. Well, we've got so much more to see. So let's move along. And this is like so much fun. So let's keep it going. We have moved about 7 feet from where we just were. So what are we looking at here?
This is another, like, one of my favorite places in our playground. So this is, what we looked at earlier was what we call the hardware in the loop system, or like it's more focused on testing the ECUs, the behavior, the communication, the faults. This is now a test system for the interaction for the infotainment system, and then the interaction between the infotainment and the rest of the car. I mean, infotainment is so important. I mean, that's the face of everything that we do. All user interactions happen through infotainment.
Well, and especially for Rivian, because so many automakers would never say what you just said. But it is, I think, a lot of the reasons people buy a Rivian now is because of infotainment, connectivity, and just the updates in general.
Exactly. And we want to make that experience as good as possible. So obviously, every time we add features, you see here some of the screens that I love, like camp mode. This is really my favorite. Our drive modes, which is one of our most loved applications.
Love it.
We need to make sure that all these applications are healthy. So what we do is we have all these automated testing, which actually, like, there's a mix of what we call structured testing, which is we would come and test specific scenarios, but then we have what we call unstructured testing. So we would come and stress the system like completely randomly, and then see how things react. Actually, right behind you, Kyle, I mean, this is like some of the, so the nerds would love this, but this is some of the really super details that the team monitors every time we have these different software builds. And then we would go and track, okay, how is the UI reacting? What's the frame rate on the screen? How snappy things are? Are we consuming more memory? And then in some cases we do. And but the beauty with these systems is they're all connected. So that allows us to, okay, every time we detect those anomalies, we have logs, we have information so that we can act on it. And this is why, like, in every one of those updates, if we detect that in the long run, okay, you're using your car for 30 days in a row, and then, okay, we start to have some patterns of issues, we have that information, and then we can act on it. You asked me earlier about replaying scenarios from the field.
Yeah.
This is actually like a fantastic testing environment for it, because what we can do with this is we can replay the entire Ethernet traffic in the car, and then we get that into the infotainment system.
And then you can simulate it and repeat it.
And it's magic. Like sometimes we see sequences, when there's issues that happen in the field, incidents, whatever it is, and you see exactly what happens in every screen. You see it real time.
And one thing, like just a recent update that you did in the last update was bringing the climate menu up.
Yes.
It's so much faster now.
Yes.
Did that have anything to do with looking at field data and bringing it in?
That's exactly it. Yeah. Which is like we monitor the reaction of how fast is the UI in each of the use cases, and we saw that the HVAC application, the climate application, was taken longer than what we want. And we prioritize that in our list of fixes.
It's amazing. And it works. It's as fast as you can hit it now. Boom, it's up.
Exactly. Now, we have one of our surprises for you, Kyle, today is what we call this energy app.
I was going to bring this up because this looks totally different from anything I've seen.
So it's new. And actually, see this.
I love it. So you can change its little character.
There's more to it.
That's amazing. Okay, so all I'm going to do is hit this as I go down the road now. That's amazing.
But before we go into all the nerdy details of the energy app, and we'll drive it in a car. Great. Actually, the developers and the team who made it happen. I wanted to show you this gear guard because this is really, this really shows who we are. We want this to be a fun experience for our customers. We want them to love coming into their Rivians and then enjoying the time that they have driving Rivians. So every time we have the opportunity to add those playful moments, we allow ourselves to do it.
I love it. It's so great. So I guess we're going to go for a drive, experience the new energy app, meet the people.
Yes.
And yeah, I don't know what to expect, but I'm looking forward to it.
All right, let's do it. I guess you need to put my
No, it'll use the audio.
audio, yeah. Okay. Awesome. All right. Kyle, we're super excited to show you the new energy app. So we have in the car with us Mansi, who has been driving this since a while.
And she's also been on the channel before, right?
Yes.
You were in for the dual motor launch.
That's
We
right.
had you in, which was
with
great.
you. That was super fun.
Yeah, we were allegedly not sliding super hardcore around the track. It was all good.
No comments.
And this is something that we're really extremely excited about. Why are we, first of all, why are we doing this? I mean, what we see is that there's a lot of customers who have that anxiety to go to EVs because it's hard to understand charging. It's hard to understand where your energy is going. I mean, your channel, you guys did a fantastic job to really explain that. The challenge is not everybody would go to those videos.
Of course.
My dad, my mom would not necessarily understand all these nerdy details.
Yeah.
So what we've been thinking about with the team is, okay, how do we make that as easy as possible for our drivers? How do we demystify the energy experience in a car? So whether it's your energy in terms of how your vehicle charges, or your energy out, which is where is your energy going. Obviously, the audience for the application is a mix of people who love data like you guys, but then also all our regular customers. So this is why you will see that there's, instead of just showing the data, what we try to show is insights. We try to coach the drivers, have them understand, okay, where is my energy going? What will I be getting as range as I'm driving, and why? Because sometimes your range goes up, sometimes it goes down, and you don't really understand this. But then at the end of the day, it's all physics and math. And what we're trying to do is make that as easy as possible. And then with that seamless integration that we have, for example, between our charging system and then our energy system and then the rest of the car with the navigation system, we want to give people peace of mind. So we want them to really optimize how they go to how they plan for charge stops. I mean, you know this really well, but if you go from 10 to 100 for each of your charging stops, at some point there's very diminished returns depending on your cell chemistry. But this is very hard to explain to non-technical people.
Absolutely.
So how do we make that easy, and how do we make that embedded in the entire experience without our customers thinking about it? So that's really the whole idea. It's our first attempt, and actually would love to get your feedback because as usual, I mean, the magic of over-the-air updates is we will continue working on this and then make it better over time.
Well, this is so key because maybe some of the viewers have seen Scott on our team recently got a R1S. We got her a dual motor, and it's her first EV, and I've learned so much just by watching her figure out how an electric car works. And I'm like, oh my gosh, definitely not everyone watches Out of Spec, very few people. It's just for the nerds, and anyone buying this as their first EV, or really, even if they've had electric cars, just getting them to understand energy better is like the most important thing. And almost no other automaker is really working on the explanation side properly. So I genuinely haven't seen this energy app yet. I've just heard about it. But Muncie, you're going to tell us a little bit about this.
Yes. All right. So our brand new energy app.
Boom! First time seeing it.
Is, as you can see, so we wanted to show you a little bit of something.
What the heck is going on? So you've got a bunch of different graphics going on here.
Yeah. So exactly to Wasim's point, right? We want to make it digestible and palatable for all our customers. You know, we have our prospective EV owners and new EV owners and their families. So this kind of gives a fun look and feel for it. But these items here, like the tips and the numbers, which is a projected range impact, builds the story between, the efficiency graph we have on the driver display, as well as the range bill. So it really builds that, experience end to end. And then in the middle here, you can see, like, let's say we look at the last 24 hours versus, since park, you can see a real-time energy consumption graph.
Yes.
And obviously this is like, caters more towards the enthusiast, but at the same time.
Yeah, but then you've just got this little thing right here, which this is probably pretty hard to inference. Wasim, do you use any AI to make any of this stuff work? Or is it all programmed in? Okay.
Yeah, but like right now, this is like our first stab at it, right?
Yeah.
So right now it's this probably like, it might seem pretty small,
Yeah.
but calibrating this probably took the longest because it's not just the observable and measurable data, but how do you filter it and how do you make it such that it's not changing too fast or too slow? It has to be like it has to be it has to have the right feel for it.
Totally.
Right?
And it's like, I just love that it's something basic. Climate control's working hard and we have a pretty high range impact. I've got this thing set to max cooling right now.
Yeah.
To me as an EV driver, I go, yeah, I'll burn a little bit of juice to cool the cabin, but people may not think that way.
Exactly.
And so already I'm like, okay, this is on the right track. That's really cool.
Yeah.
Love that.
And then, as you can see on the right here, this is just the session details. It's all of the cumulative energy consumption, just the distribution across the different systems. So you can see here, you have your gear guard, climate, outlets, and other electronics, hence vehicle systems. And so this, as you can see, like every time it reflects the time scales throughout, and then same thing again. So it'll show you for each time scale.
And we've got just a small number of data on here at the moment because the truck hasn't been driven much, but I'm about to drive this truck back to Colorado and we are going to load this thing full of data.
You're going to see the gear guard react differently throughout.
It's going to do some funny stuff.
Yeah,
okay, cool.
Absolutely.
So I'm noticing a charging and an energy monitor. What is that all about?
Yes, so this is obviously your energy outflow, and then your energy in is where we see, and this is actually, you've seen the previous energy app, right?
Yep.
This took that to the next level in terms of making it a lot more interactive. And also just the aesthetic feel for it was redesigned to also make it such that it's extensible to the future platforms with R2.
Right.
And and then same thing here. This right panel is always going to be showing you a more cumulative energy distribution across the systems. And obviously for our last chart session, so it's just showing that for you. I'll show you battery pack, climate, outlets, and systems. So whatever is relevant to that vehicle state.
Amazing. And you had something similar for the charging session before, like it would give you a summary of how many kilowatt hours went to climate.
And that's exactly what this is. Like, this is a way more palatable,
Yeah, for the nerds before, I was like, that's cool. But now, like, someone like my mom could go here and be like, oh, okay, I kind of get where stuff was going. That's really
and that was the entire goal here, like Wasim was referencing too, right?
Yeah, and charging curves built in. What the heck? That's amazing. Are you kidding me? That's so cool. And it remembers the last one as well. So we had basically this in the Rivian app before.
Exactly.
But now it's in the car.
Yes, it's at parity with some more stuff. So what we've also added here, as you can see, there's these gray bars here, right? So these are essentially, we have an onboard charge time estimation model, and then we have a cloud machine learning based model. So we're arbitrating between the two to get you the most accurate charge time estimate we can while you're charging.
Good. That needed to be improved, by the way. So I'm glad that's getting there.
Yeah.
Also, you can now lower the onboard charger. I guess you could do that before too. So that's
it's
cool.
just a different
way of doing
But now it keeps it between drives, which was one of the big feedbacks.
Yeah.
Nice.
There's also something else. I don't know if you noticed, Kyle.
Yeah, you haven't noticed it yet?
What? What am I supposed to be looking at? Manual preconditioning?
Yes.
Whoa, that's amazing. So what's the target for this? You just target a certain average battery pack temperature?
Yeah, so the way we've done it to make it, I guess, most intuitive is we've binned it in the different, charging stations that you could have around you. And we go for a 150 kilowatt, but then right now it's grayed out because it's pretty high. Right? So we'll show it to you once we come back from the drive on another vehicle which has a lower SOC. But the way it'll show up is we'll optimize the charging for that 150 kilowatt, maximize it, but then in the feedback it will show you whether you're ready to charge up to 50 or 100 or 150 or 200.
Nice.
And that's how it gives it a little more intuitive feel for it.
Man, we need it to be like negative 10 degrees outside.
I know, right?
Show that. It's a little too warm. Okay, but that's really cool. I can't wait to play around with this, especially as we do a lot of testing either at test facilities or even at our own chargers that are not in the Rivian nav. It's great just to have a manual preconditioning option.
And maybe you're at a charger and now you want a manual precondition to get even more oomph out of it. So there you
well, we always want more oomph out of the chargers. So yeah, let's go drain this thing a little bit, get some data, see how that all kind of works. And man, I am thrilled with this so far.
Sweet.
So cool.
All right. I threw in a charger that was close by.
Oh, this looks a little bit interesting. Okay, cool.
Yeah, I just threw in a supercharger.
Yep.
That's 3-ish miles, but we can always, go around and see.
Well, let's go. Let's at least cruise over there and see how it goes. Love Gen 2 cameras, by the way. They're so nice.
Awesome.
Muncie, we are preparing for fast charging. Now, it's not the best example because we're at 96%.
Exactly.
This is not the out-of-spec lifestyle. It's not your lifestyle.
Nope.
We're not navigating to chargers at 96%, but you have a really cool feature. Rather than just showing that you're preconditioning, we can actually go into the Energy app and it will tell you, hey, if you plug in now, you'll get up to 25 kilowatts.
Exactly. And then this also has been beyond, right? So if you were at a lower SoC, and you could be seeing it up to 50 kilowatts, 100 kilowatts, 150. So as you can imagine, this is something that it kind of combines the pieces that have been asked for, but also gives the user a little bit of expectation in terms of what they can achieve at a charger.
I absolutely love this feature. It just really sets the expectation as to what will you get when you get to the charging station, and super important. So fingers crossed we can actually plug in if it's open. We are in California dealing with some busy chargers around here, but let's go see what we can find. And it says electric vehicle parking is upstairs.
He's head of software. Oh, okay. You guys had a big revision.
There's also been an entire refactor and re-architecture of the notifications.
Oh, wow.
And introduced a lot more intuitive ones, charging or charging stopped.
So
charging
all
slowed.
notifications?
Yeah, all charging related notifications. And it's also the same thing in mobile. So you get the live activity, obviously, as well as the push notifications as well.
All right, so we're juicing at the moment. But
obviously
why does it show miles per hour as the default? What's up with that? Oh, I love this. Charging speed reduced, package
so that's
near the charge limit.
part of the new notification.
Okay, very cool.
On the top of the banner?
Right there.
Yeah.
So it's obviously on both screens, and this is the trip target feature which we've been talking about.
Okay, so it says charge to 97%, unplug, and then you can make it to your next destination.
So basically, it's as soon as you have enough energy to continue on to the next destination and hit the road again.
And what does it target for the arrival at the next charger?
So that's based on whatever we've obviously set our preferences.
So you can say I want enough to get there at 5% or 10%
and
or
then it'll
30%.
adjust accordingly as well.
Very nice, very cool.
And fun piece is you'll also get notified on the mobile app. So if you're away, you're at eating a lunch or dinner or something, and at a charger, you'll know when to resume your trip and come back to the vehicle.
Okay, this is clutch. This is amazing. This is what we've needed.
And
there's
you see the same thing on our charge graph. So charging graph, you can see there's these sort of predictive aspects. So we show you what you could achieve as far as your peak power goes, and then you have your live data in green.
So when this is saying 61 kilowatts at 91%, 59, is that what we're doing right now?
Yes. Yeah.
That's really good.
Yeah.
I think that's better than before.
That's part of the battery management optimization.
So you guys
just telling you about
the charging curve a little bit then. Okay, because that's really good. I haven't done a charge test on a MaxPack in a while, but that seems...
I think you better.
Yeah, especially with those.
You should maybe arrive at 0.
Yeah, this battery doesn't know what's coming for it. We're about to do some testing. But how do we show this number in kilowatts over here rather than miles per hour?
So this doesn't...
okay. Holy smokes, 53 kilowatts at 96%. Did it used to do that? I don't think so.
No.
But now it does. We like part of those battery management optimizations that I was telling you about. It's also expanded the curve in terms of the max temperature and the min temperature.
Oh, nice.
We can achieve,
So
and
we can-
that's
we can
why
push it
it's
all
actually
over
the cell curves have slightly been expanded.
Nice. Well, that's 50 kilowatts at 97%. Holy smoke. And this is a max pack, so it's not like a software limited anything.
Wow, it is what you get.
That's really good. Okay. I did not expect that. So now I'm looking forward to the road trip. Hell yeah.
He was dreading it. This has changed everything.
Yeah. Does it now do like 700 kilowatts as well? Or
Unlock with software, right?
No, well, thank you guys for showing me all this. I love the detail that you go into. I love that it's really explaining what's happening. I'm sure it'll also show, hey, pack is frozen if you plug in the middle of winter with no preconditioning. And will it even do some recommendations in the future? Like, if you don't precondition on the way to a charger, will it say, hey, next time you should probably precondition?
That's the idea in the future.
Yeah.
That's really the idea in the future. And what we want to do is, like, as we get that curve really, really dialed well with machine learning, we want to include that in both the navigation planner and then really have that coaching of, okay, it's way better for you to spend 20 minutes to get this optimized charge rather than trying to go from, say, 10% to 100%, because at some point you will have diminished returns.
Yeah, this is really amazing. And just being able to scrub back in time and be like, oh, okay, I hit max thermal limits here, that's where it died or something, that's really cool.
You see the same thing, right? As you can imagine, you have your trip target all the way here, and same things on your
So
mobile
this is
app.
kind of new.
Yeah, exactly. So we were trying, like, making sure, your mobile app is at parity with vehicle.
Wow, you guys are killing it. This is so cool. This is so cool.
Yeah.
Love it. Well,
now there's a ton of changes as well behind the scenes. I mean, not just the UI for the Energy app, but the team really worked super hard to continue to optimize the charging curve. I mean, Kyle, you gave us tons of feedback there.
Sorry.
Which is fair.
Maybe too much feedback.
But the team wanted, in like typical Rivian fashion, we wanted to over-deliver. So we're not only improving the charge curve on the max pack, but then also on the large pack for Gen 2, on the standard pack for Gen 2, and then the max pack for Gen 1 as well. Actually, Vivek has a ton of details.
I can show you. Perfect.
Got some stuff here.
It was thanks to Jennings and team. They put this together.
Okay, so we've got cell limits and pack limits. Just put those to the moon. If it's not going to explode, just hold it right there from exploding. Okay, hell yeah. And
so one of the things that we did was we took a first principles approach to what the charging performance is and what are the stack up to figure out where it can be optimized. So what we did over the course of time was to understand optimization across multiple layers, and that's what it's called out. It's not just software, it's also hardware. Along with software is what brings all the improvements. So we are looking at, if you scroll through, there are 4 details there.
Oh, here we go. Can you email me that?
Tanya will.
Okay.
So we'll have a deep dive with this with the right people, but essentially what this is calling out is for not just the battery management system, there's also other systems that are contributing to this. So there's thermal management that's also taking a part in this, where we are optimizing the battery performance and the charging performance for making sure that we are getting the right thermal on the battery side. And then as you go through, there's a table. If you go,
yeah. So this is what we're noticing right now on the max pack, which this is increased limits at high SOC, great, and at 25 to 35 C, which is right in the middle when you're pushing. Standard pack is significant improvements up top, so beyond 50% and at high state of charge. So we really do need to get a standard pack in for testing. Wasim, if you can find us any way to get one to borrow, because the press team doesn't have any, that'd be cool.
All right, we have a deal.
Yeah, all right, that's I just need it for a week. And then the large pack is juiced from 175 kilowatts to 215, so they're not getting full performance, which is amazing to see.
If you look at it in terms of time, right, you'll see it in the later slide, it's like a 3 to 6 minute improvement across these packs.
Well, thanks for sharing all of this with us, and nice work on helping us get some faster charging over here. You know, obviously you're stuck with the hardware that's in the vehicle, but if you can optimize it as best as possible, then that's all we can ask for as customers.
And like Wansi mentioned again, this is not just 2 people. There's like a 50, 100 people who are just working on this.
Really
and
cool.
we've been always looking for more feedback. So more comes in, the more we're going to improve our performance throughout.
Well, this is certainly a major update to the charging performance up top on this pack. So
we're super excited.
Yeah, I'm definitely thrilled. So yeah, thank you guys, and yeah, we'll head back to the office now. Jordan, we're about to jump into an engineering vehicle. You know how we keep complaining about the thunk, the dual motor clutch connect issue?
Yep.
Okay, now in order to get their EPA rated range, the car has to be in a key up setting in order to, you know, do the auto clutch disconnect, reconnect. Wasim has a prototype software on this car that's kind of their idea on how they can actually still get the rated range so people know that it can go really far in a charge, but then also not be so clunky and maybe stay in all-wheel drive mode all the time. So we're going to go see what this is all about.
We've heavily requested this.
This is like my #1 request from Rivian. So let's go see what their solution is. Guys, you join us in that engineering vehicle I was telling you about, and there's a couple cool things that we can show here. So before we show you the cool new feature that we've been requesting, on the preconditioning topic, because we were pretty much fully juiced in the other one, we can come to the new energy app, of course, and we can hit prepare for fast charging. Now it says some energy will be used when you're preconditioning for DC charging, which totally makes sense. It may take up to an hour or more. Cooling the cabin will slow down the process because it shares the thermal loop, of course. So it tells you every reason why you shouldn't precondition, but you really should precondition.
And the reason for that is to make sure that we are always getting customers to navigate the charger, because that's the most optimal way to precondition your vehicle. But there's also the opportunity and the option for customers to be able to precondition on demand. And that's what we are currently doing. So you can see that as we are warming up the battery, you will show the ready for charging. So it's going to give you rates at which you can charge. So you start from 25, it bumps up all the way through to your peak charge rate. And that's what your battery is going to be set up for in the next session.
Yeah, I'd love to see actually this temperature data shown along here. And then you can have like a little progress bar.
That's actually a great idea.
Yep.
Okay,
that's something that we'll bring in.
Yeah, cool, nice. And then, all right, so I've already explained to the viewers that the clutch reconnect and the dual motors, it has to be there by default to get the EPA numbers.
Right.
On Tri and Quad, future Quad, it will have an all-purpose mode, which is just all-wheel drive all the time, and then a conserve mode, which will automatically connect and disconnect. But with the dual motors, you just have all-purpose, and it always does clutch connect and disconnect. So you've come up with some solution to do lock it in all-wheel drive, I guess. So what is it?
Yeah. So just to set the context here, as you mentioned, that has been our modus operandi, is to make sure that dual motor customers get the maximum range, and all-purpose was set to provide that. Now we have heard feedback from customers that they want both, an optionality of being able to get the 4x4 permanent with the drivability that you get with it. So we have heard that feedback. We have heard your feedback as well. So what we're bringing in is the optionality to do just that. So when you go into your drive modes, now you are presented with 2 options. So you have your all-purpose, which is the new all-purpose, where it is going to be in 4x4 permanent. So it's going to be all-wheel drive all the time. So that is going to give you the optionality to be able to punch it when you need it and get the response that you're looking for. And conserve now comes in to fill in the gap, where it's still going to give you the max range mode. So when you're road tripping and you're not looking for the throttle response that you want, you can put it in conserve mode, go on a road trip, get the maximum range that you're looking for, and still be able to get the EPA range estimate that you are set up for in a dual motor. So you get the 410 plus miles on range for conserve. And all purpose is going to give you that balance of range and drivability.
And so this is very similar to the way Tri and Quad motors are set up then. However, I imagine the key up setting is going to be conserve mode in the dual motor.
Yep. You got it.
Yes.
Yep. And then how often does it reset? Every 24 hours, or what is it? Is it every drive cycle?
It's every drive cycle, which is 4 hours apart. That is something that is set up by the regulatory board. So that's what we are adhering to.
Yep.
So if you're out of the car and it's 4 hours, then it sets it back to conserve. Turns out would set it to the most optimal ride height for the most efficiency.
Right, so you'll do auto ride height, so it'll drop at highway speed, of course, which, you know, it's fine when you're trying to get max range out of the car, but if you want ultimate comfort and just have an all-wheel drive all the time, one click away to all-purpose, which is great.
Right.
And then that just targets, you know, dual motor all the time, keep all the safety features, full regen, everything like that.
Right. And in addition to that, it's also the user preferred ride height. So if you plan to set it at standard or low, it's able to remember that. So the next time you come into all purpose, it's going to be that ride height setting.
So the only thing that would be the cherry on top for all of this is if I could just boom, hit a hotkey.
I'll let Vasil comment on that.
Is there a regulation that says I can't just get in? Because like in park, these aren't used for anything on the right side. So let me just go Kyle mode or, you know, all purpose.
Right. That is something that we are looking into. We need to make sure that we are setting it up the right way for customers, and we want to also understand the feedback from customers as well, so that it's intuitive enough for them to be able to hit this button, change the mode, and be able to set that.
Otherwise, you just go there, done. Right. It's so easy. The only problem that I see is like I'm normally in reverse, backing out of the driveway, and you can't like do it all at the same time. So then you could just hit a button. Exactly. But honestly, this is such a huge improvement from where it was. I totally understand the need to start up in conserve mode versus all-purpose. For the viewers at home that might be slightly confused, I'll do a show, a little podcast episode explaining all of this, but I'm really thrilled that you guys took the feedback from your dual motor drivers and definitely made this 100 times better.
And thanks again for your feedback and for viewers' feedback as well. That's exactly why we listen to feedback. We want to make sure that we're making changes that are focused on customers and focused on drivability that they are looking for.
Yeah, this was the number one thing we needed. Yeah. So now we're good. Okay, great. So yeah, everyone go buy dual motor Rivians now. Jordan, we just spent literally the entire day here at the engineering centers.
Right, I feel like the sun was rising when we got here and now it's getting ready to set.
Absolutely. And what a day. We learned so much. We didn't film it. We just spent quite a bit of time with RJ and the R2.
Yep, couldn't show any of that.
Couldn't show it, but
that's exciting
we
stuff.
did get to check out the cool wrap that they posted about recently.
Yeah, they did share that.
So, I mean, I just think Rivian's in such an exciting spot, not only with their own product line, but the ability to get a lot of the software, mostly hardware architecture into Volkswagen Group that we've been discussing. It really is interesting how exciting things are around here. And I'm not even talking about driving dynamics or chassis performance or stuff I usually care about. This is just software.
Right, and even though the software is so good already, every time we make a suggestion or something, or even people commenting on our videos, Rivian's watching and listening, and then they implement it very quickly.
It's pretty amazing how they literally do read the comment sections of our videos and like have AI analyze stuff and then improve the trucks based off of that and the user feedback they get on X and Reddit and so many other sources. With all that said, I'm about to take this truck. It's a dual motor R1T with the new Energy app on a road trip, about 1,300 miles home to Colorado.
Good luck.
Thank you very much. I'm excited to try out the new Energy app. I'm excited to try out the new thermal maps on the battery pack, as well as the charging performance. I'm gonna write back to the Rivian team with my findings, and it'll of course be in this video. And with all that said, we've got a road trip ahead of us, dude. I can't wait.
Hell yeah. All
right, well, thanks so much for watching this inside of Rivian software tour. This was a really cool opportunity that came together. And we'll see you all on another one again soon. Bye-bye.